So, welcome to the Mass Timber Symposium. Well, a funny thing happened last night. We were having dinner with some of the panelists. Of course, they said, "What are you doing in town?" And they said, "We're at a symposium." They said, "What the hell is that?" Anybody know what a symposium is? It's not, apparently it's not an architecture made up word, as we started to think. It's the definition is a convivial discussion, especially as held in ancient Greece after a banquet. So we do have some food on the other side. We'll have lunch today, and so we'll be eating and we'll be talking, and what we've tried to do is amass different experts to talk around this topic. And I'll describe a little bit more about this topic and other things and why we're doing what we're doing. So my name is Carl Dahlman. I'm the Dean of the College of Architecture and Design at Lawrence Technological University. The College of Architecture and Design prides itself on being focused on design, immersed in technology, because we are a technological university, and we're also grounded in practice. We believe that all of the world's easy problems have already been solved. What remains is complex, wicked problems that cannot be solved without multidisciplinary creativity. In support of this belief in interdisciplinary and multidisciplinary design, we initiate the education of architects, interior designers, graphic designers, game designers, product designers, and transportation designers. These are all the degrees that we have within our college. We bring all of these students together in the first year to educate them broadly and in a multidisciplinary environment. As seniors, all of the students in our college take a design leadership class, which also introduces topics of entrepreneurship, organizational design, leadership frameworks, and collaborative strategies. All of these, again, in support of the belief that designers must be able to work beyond previously and narrowly defined disciplinary silos. While COAD, College of Architecture and Design, has a defined and sustained disciplinary diffusion within the college, collaborations that include engineering and business have been much more difficult to forge. Changes to de-silo higher education have been slow. Here I'm not talking only about LTU, but I'm talking about higher education in general. These changes have been slow, but this symposium is one step in the process to act as a fulcrum to bring about deep and impactful changes. Last March, the college was approached by Gensler to make a proposal to their charitable gift fund. They solicited proposals from 4 schools to take on the issue of multidisciplinary collaborations. From their perspective and practice, they felt that these collaborations and working in teamwork were difficult to achieve. So together with, well, separately, but the other university, 2 universities benefited from this grant. University of Tennessee, Knoxville, which is running a program this semester, and LTU were awarded this grant. The Gensler financial and intellectual support offered with this grant allows us the opportunity to both attract experts and support our students beyond the college, to put designers in pivotal positions on campus to initiate these types of collaborations. So I'd like to acknowledge Gensler for the support. Dale Geyer, the chair of the architecture department, is in the back, was instrumental in writing this proposal, along with Kevin Finn, our VP of philanthropy. Dan Winey, who was one of the people at Gensler who initiated this, but was not part of the judging, is a trustee at LTU as well. Support for the course, we have, I think, some of our faculty here. Sadashiv is here in the front. Valeria is here in the middle. We have business represented here, and I know that we've also been working with engineering, who I think weren't able to attend today. Is that right? Any engineering students? No, they couldn't be here today. These are these silo problems, right? Which in the end are not about desire, it's about scheduling classes. This tends to be the biggest problem with anything. And so a little bit on some of the things that are happening today, how we're going to run, what we're going to do. So first of all, you're in a space that so you're in the middle of an exhibition called Constructing Futures. And so this was a nice opportunity through the month of design. And so for those that are visiting Detroit, Detroit is a UNESCO City of Design, the only UNESCO City of Design in the US, and you're here while this is happening. So September is the month of design. The exhibition is curated by myself and Sarah, who's standing in the back. Partnerships with Bedrock, so they're over there, Matthew and Ryan. So we started the conversation about this exhibition and the activation of this space probably in February of last year around a notion of what's the future of construction. How does AI, robotics, the manufacturing history of the area, how does this begin to inform the way that we think about construction? And so we had funding from the President's Office at LTU and support from Bedrock and the Urban Tech Exchange, a number of sponsors as well who helped to support the construction. Some of what you see, the exhibition of images around the perimeter of the space is about the submissions internationally from about 25 different countries. About 60 designers represented. There's 500 images, and they're all generative AI images that speculate on the future of construction. And so as we have time today, take a look at all of that work. The space that we're in, a little bit thinking about the construction that was done within the space, thinking about a space within a space within a space, and these types of nested things, which for us is a reference to Baroque architecture in Rome. The incredible ceiling here, thinking about the ceilings of some of those other spaces. And so that was the international call for those images. And it allows us to do programming like this month in the space and to continue to talk about what the future of construction might be. So the symposium on mass timber. So mass timber, what is, maybe probably everyone that I'm looking around is engaged in the class, but I thought maybe someone might just come in off the street. So why are we talking about mass timber? So it's basically a set of wood products known for their strength, durability, and sustainability, but also made up by taking smaller, younger wood and putting it into larger elements. These new materials, products, and techniques bring new perspectives for all building types, changing the way in which projects are designed, built, and experienced. And this holistic and synthetic idea about construction inevitably comes with the need for a range of experts, like many of whom are in the room, as well as an environment of collaboration, which again has been made possible with the studio. So this is an initiative and the reason why we bring all of you here today and tomorrow. Additional support from students that helped build the space, Ryan and Matthew. And so a little bit on how we've set this up and how we're organized, and I think we may, Nate, did we make a change? Okay. So far, no changes. I'll zoom in a little bit. We were talking about possibly doing some shifting. So here's what we're going to do between today and midday tomorrow. So we have students. The student groups that are working within the studios are going to present some of their work and the research that they've done in the first part. At the end of the symposium, the students are going to get their sites, right? Students are going to get their sites for the next project. We also have field trips planned for the students to visit manufacturing spaces as well as buildings that are under construction with mass timber. So this morning, we've got a mix of a couple of student groups and a couple of panelists. What we'll do if we run on schedule, we're still currently on schedule, we will have some Q&A and hopefully find some overlap and connection between the panelists. We'll break for lunch. We'll have lunch in the space. We'll have an afternoon session, same type of format. Two student groups mixed in with the 3 presenters, and then we've got a little bit of buffer in case we run long, but we've got some time for networking and some time to look around the exhibition this late at the end of the day. And then tomorrow, same schedule, breakfast from 9 to 10, and then a set of student presenters and panelists tomorrow, then we'll stop with lunch at 1 tomorrow. The other, did I forget anything? Looking around, did I forget anything? If anyone needs to use the bathroom, talk to Jen, who's sitting over at the table. The bathrooms are downstairs, and we need a key card in order to get access. So that's one of the complications of being in a space like this, but it's okay, we can do it. Sound good? Any questions? We're excited?
You guys hear okay? Are you sure you don't want to use the mic? You guys hear okay?
Yeah. Can you hear all right? Yeah. Sometimes, so one of the constraints, we talked a little bit about the construction, it was built very quickly, and we couldn't have any overhead planes, so because of the sprinkler system, as you can imagine, but it's also open to the lobby. So throughout the day, we'll hear people coming in and going, and so we'll just try and make it work. If anyone can't hear, just let us know and we can talk louder. We are making a change. So the business group is today, 3:15 today.
Yes. So not the engineering, technology.
Okay.
After the education group at stuff.
Okay. And then how about this? How about the students that are here? Can you raise your hands? The reason why I'm doing this is to, again, shame all of you. I came in and they were all sitting in the little room in the back all together, and this is their opportunity to meet the experts and engage the experts and the practitioners and other type of people. So my hope is to be able to get some mingling that happens that way. Sound good? Make sense? Okay. So let's try this. Let's have we're going to start off with the education student group. Put you right front and center. Okay? Let's see if this works. We're just going to do this, right?
Surround it. Okay. Well, hello everyone. We are the educational student group. We won't go into too much. Carl kind of introduced us well. But each group was tasked with researching a specific typology of project under the scope of Mass Timber. So getting into who we are as a team, my name is Logan Caruso. I'm a senior architecture student, and I've worked at architects for the past 2 years.
My name is Miranda Claddy. I'm also a senior architecture student, and I interned at Symposium Architects this past summer.
My name is David Jaskovich. I'm a senior architecture student and interior design student, and I've had the opportunity to work for Liquid Box for the last couple of months.
So getting into our typology, again, as I said before, we were tasked with researching educational spaces. So we broke that down into a couple of categories, mainly core learning spaces, administration spaces, and performance spaces. And then these are kind of informed by the actual educational occupancy, which we looked into at the start of the project. Obviously, public education was key, with branches into a couple other programs that we have light research into.
So a large part of our research is dedicated to investigating why we would like to use mass timber and where it's going. And we organize this into the 5 tenets of our research. We have economics, which looks at cost minimization and how the schedule can be optimized. Logistics, how does it get to the construction site and onto the manufacturer's plants. Integration, how does it work with the structural grid and the integration and enclosure. Health and wellness, all of the interior occupant experience, acoustical and finish qualities. And sustainability, so the cradle to cradle, cradle to grave, carbon footprint, ecological impact, and the biological attributes that go with it. all of that turns into the harmonization of elements, which in turn can create a mass timber experience. And that's important to us because we spend over 21,000 hours in a classroom over our lives. And if you break that down further, 19,000 of that is spent in the first 13 years of education, and a couple thousand more pursue higher ed.
So to look at some of the history of mass timber itself has, timber and logging itself has a very long and rich history within the state of Michigan. And that is relevant because there's ongoing research within the state of Michigan that is relevant to mass timber right now.
So what is mass timber? So it is defined as structurally engineered components, load bearing made out of engineered wood products. It is currently an emerging construction method due to its high durability and strength, as well as its natural design flexibility. And then we start looking at some of the applications of mass timber and the different products we get from it. The main two we focused on are CLT and GLT. CLT being cross-laminated timber used for floors or used walls, consisting of dimensional lumber lapped in perpendicular directions. Sorry. And then glue laminated timber, which is in parallel directions, often used for beams and columns. And then we also have a lot of other categories that we won't cover out too much, but dowel laminated timber, nail laminated timber, mass ply panel, laminated veneer lumber, laminated stranded oriented strand lumber, and parallel stranded lumber, each of which has their own unique uses and opportunities. And then, defining that into construction types, we focus in type 4, which is the typical mass timber, which branches into type 3 and type 5. Type 4 is then broken down into types 4A, B, and C, which all define the allowable height and amount of substrate. So, our next part of the research was taking actual manufacturers and kind of base our research around. So our primary Oh, okay. I don't do good with microphones. Can you guys hear me okay? Okay. Sorry about that. So could you guys hear before a little bit? Okay, cool. So our primary manufacturer that we chose is Mercer Mass Timber, who offers an integrated design process starting with the selection of material which is appropriate for the project, moving into vertical members, including your glue lam, and then your horizontal and slab members, including your CLT, then into an optimization process to effectively create the structural grid, creating assemblies using pre-engineered systems, and then eventually sequencing to ensure a swift and efficient design process. A couple of different products they offer. Again, this one focuses primarily on CLT and GLT. And then these are some of their engineered build systems, which they offer in BIM models to be rapidly kind of produced and effectively deployed in different construction scenarios. And then a couple of secondary manufacturers that we chose to kind of round out the construction process. We chose Rothoblast for their wide array of fasteners, including concealed bracket hangers, and then Global IFS for their integrated floor systems, such as underfloor air distribution. And then looking into our first of the key tenets, we have economics. So overall, we found that mass timber can result in a 15% reduction in P&G charges, or preliminary and general charges, as well as a 50% reduction in relative labor costs due to the lightness of the material and the reduced workforce required. And this can be further optimized by choosing correct structural systems depending on the project. So a couple different examples here, whether it's better to use less columns, more girders, more columns, less girders, that kind of thing. And then scheduling impact is another huge tenet of this kind of research category, with a 25% reduction in overall construction time when using mass timber as compared to traditional building methods. It is 80% lighter than its steel and concrete counterparts. And then another kind of fun fact we found, it has a 1 to 2 day construction time for a CLT elevator shaft compared to a CMU elevator shaft, which is typically 3 to 4 weeks. And then for each of these kind of tenets, we found a case study that really embodies these principles. So for economics, we chose the Forest History Society, built by DTW Architects and Planners in 2018 in Durham, North Carolina. This project was a result of a lot of community funding and a lot of community buy-in, with a projected budget of $4.5 million, but they raised over $6 million, much of which came from different manufacturers donating products, as well as philanthropic pledges for the community. And then scheduling-wise as well, this had an extremely expedited process. with the construction taking place roughly over a year and then opening immediately the year after. And just a couple of key takeaways, what we kind of talked about before, the maximization of the schedule or reduction of the schedule, the cost minimization methods that can go into making this truly a cost-effective method, which is one of the main concerns.
So our next tenet is logistics, and this is how mass timber gets from where it's harvested to the manufacturing plant and to the construction site. So this is where our project location is in Detroit. This is where our primary manufacturers are, and this is where all the different kinds of species grow. And all of that's relevant because proximity matters in terms of embodied carbon, and it's important to size the kit of parts correctly to whatever method of transportation is being used, whether that's flatbed trucks or by train, which is the two primary options. And these can kind of be embodied in the Edward J. Ray Hall by the SRG Partnership in 2021 out in Oregon. Something that this case study does really well is its commitment to sustainability, and that's evident through its documentation of the journey of all the structural members in the building. So the CLT starts out in the Coville National Forest, which is about 450 miles from the project site, and the cutting down of this forest actually helped 40 acres of restoration in the forest. And then it travels, I think, 10 miles down to the Vaughan Lumber Brothers, and the Vaughan Lumber Brothers is a proud Mill Creek A to Z stewardship project sponsor, which helps support the 40 acres of restoration. The Glulam members, on the other hand, come from the Yakima Reservation, which is about 230 miles from the project site. And the reservation produces about 80 million board feet of lumber used in construction every year. And then it travels to the Zippo mills, and something about the Zippo mills is they can actually create members up to 115 feet in span, which is pretty cool. And some of the key takeaways of this is the importance of sustainably sourced material not only leads to a healthier environment, but it can also lead to a reduction in transportation costs.
So we've kind of looked at the front end with economics and logistics. Now, how does the system actually get integrated? So back to our kind of educational space programming, we can further break this down into long span and short span structural bays, with our classrooms and other associated spaces falling into short span, whereas gymnasiums and common spaces fall into large span. This then can be used to start creating structural grids that really amplify the core learning spaces and shared learning spaces in between. And then once we had that, we kind of started looking at this through the scope of our own manufacturer using their product dimensions to create structural grids for long span spaces such as a gymnasium, as well as the core learning and shared learning spaces. And then looking at actually integrating structure, there's a lot of good practices with mass timber that can be used, which we won't go into too many of them here for the sake of time, but such as how the actual structural system is deployed to make room for enclosure and other MEP systems, which we'll get into here. So this, again, is maximizing that enclosure potential, allowing for full height glazing by keeping those exterior girders off the wall. And then with MEP, we have a system that allows MEP to be run parallel to the beams into the rooms with a centralized core for maximum efficiency. And then a couple different methods for running underfloor systems and exposed ceiling systems. One great example of this is the Humber College Lakeshore Campus Cultural Hub. The name is a mouthful. Built by Diamond Schmidt Architects with an expected completion in 2026, and that is located in Etobicoke, Ontario. Might have butchered that. It has a very varied structure with both steel, mass timber, and concrete being used in different spaces, allowing for different programs, all the way from student dorms to large open performance areas. And then the enclosure itself, they emphasize mass timber on the outside using different sustainability methods and using the structure on the interior to kind of make room for those systems. And then the actual MEP, they have a very kind of distinct divide with the residential MEP systems being run, as we can see in this picture, through vertical chases or openings for vertical chases, being wall-based systems. And then in the open performance spaces, they're very highly specialized systems that run through open cavities in the steel and concrete structures. So just a couple of key takeaways. The importance of understanding the program and the structural system that works best with it, and then integrating your MEP and your enclosure systems with that using coordination between all the trades at an early stage.
To start to look at some of the health and wellness implications of mass timber, this can essentially be broken down into aesthetics and acoustics. So based on aesthetics, mass timber works best with other natural elements, and this ties directly into the idea of biophilic design, which helps the mental and physical well-being of the occupants. And then looking at some acoustic qualities, for sound transmission reasons, additional systems are often needed to be added to CLT panels, and the finish grade of the material can also determine sort of the composition of those systems. So for example, an industrial grade panel might be hid more than an architectural grade panel. And a good application of these ideas is the John W. Ulver Design Building, designed by Lears Weinzipfel Associates, located in Amherst, Massachusetts. So the aesthetics of these spaces, the studio and atrium spaces have a lot of exposed timber elements. And considering that those spaces are where students spend majority of their time, it kind of makes sense going back to that idea of biophilia design. And then some of the acoustic qualities there in these studio spaces, there are a mix of exposed timber and wall systems to try and keep noise from spreading in between spaces. But this also goes back to the idea of biophilic design and using wood in moderation. And then some key takeaways from this is that the material can create a more positive experience for the occupant through the use of these natural elements. And these elements also have like acoustic qualities, but usually need other systems to be added. And then to look at the sustainable aspects of mass timber, just looking at a life cycle, when a tree gets planted, they continue to absorb CO2 until they're mature. Once mature, they'll get harvested, sawn into dimensional lumber, and then either will get used in construction from there or sent off to panel manufacturing. From there, they can be shipped, constructed, used, and then disassembled. From disassembly, they can either be reused in other structural elements or in furniture, millwork, or other things, or they can be shaved into mulch, used in landscaping, or burned as biofuel. And this goes back to like circular, the life cycle and being broken back down into the plant. And a good example of this is the Santiam Canyon High School, school district. This was designed by Soderstrom Architects and is located in Mill City, Oregon. So some sustainable choices that they made were the material choice and like how community oriented this building was. So this gymnasium was originally proposed to be steel, but after Freyr's engineered wood offered to donate all of the mass material elements, the district decided to move forward with mass timber. And this project specifically uses 8,736 cubic feet of wood, which is the amount that could be produced in Canadian and US forests in a minute. And this has a potential carbon benefit of 302 metric tons. And then for the community aspects, Freyr is local to this project site. It's about 10 minutes away. And all of their materials are locally sourced. And then local business and construction companies also did all of the construction. So this has become a huge point of community pride because all of this is local, which also can lower the embodied carbon footprint. Some key takeaways from this case study is that like sustainable forest methods can allow us to consistently produce mass timber elements, and the potential for second life of these elements can also mean that their embodied carbon stays that way longer.
Next up, when all of these factors start to come together, we can start to really see a mass timber experience emerge from the economics, logistics, integration, health and wellness, and sustainability aspects of these projects. And one of the case studies that really embodies all of these is the Bill Fish Forest Stewardship and Education Center, built by Dialogue in 2015 in Ontario. So economics-wise, it had a $3 million budget, and most of that budget went into passive strategies to save operation and maintenance costs. Logistics-wise, most of the structural members were sourced within a 1,000 kilometer radius of the site. MEP systems were concealed. The enclosure utilized reclaimed Douglas fir materials that you can kind of see here. Health and wellness, mass timber is used as an exposed finish in moderation, and it has a lot of passive strategies to help with that as well, the quality of life. Sustainability, there is a lot of sustainability characteristics. Unfortunately, we don't have all the time to go into them, but some of the key takeaways, aside from the passive strategies used, there is a net zero carbon usage or net zero water usage, and there's 144 tons of embodied carbon used in this building, which is pretty low.
And then to kind of just conclude those 5 categories, uh, back to the points we made before about economics, this can have a huge impact on the cost effectiveness of the system, especially when maximized, and can shorten the schedule very effectively. Logistically, Michigan is in a unique position being situated close to a lot of spruce pine fir, as well as the importance of span selection when determining the project. uh, Integration using collaboration between different trades to create systems and grid. We're so close. I promise. Like 1 more minute. Okay, we'll run through the rest fast. Looking at health and wellness in the perceived environment that is being built, as well as sustainability, effective forest management, the embodied carbon, and the second life potential of these framing members.
So looking towards the future, Michigan Technological University and Michigan State University are both researching the potential of CLT panels within the state of Michigan. Michigan Tech is focusing on hardwood species, while MSU is focusing on softwood. And the research of hardwood is especially relevant when considering 70% of Michigan forests are hardwood. Despite this number, most of these are not high enough grade to be considered veneer logs. So finding a use for these lower grade logs would not only expand Michigan's potential for mass timber products, but would also offer support and jobs to local communities. And hopefully, because of the sponsored studio, Lawrence Tech can be added to this list. That is all if we have time for questions. Okay.
Switch over. So how about this? So I think we are going to continue with the business students. We'll just keep with the schedule that we had.
Hello everyone. We are here from the College of Business and IT, presenting you the business case study on the entire architecture project. Starting off with, my name is Nitish Nishtala. I'm a senior in information technology doing my master's. And here today we have 4 other group members that are going to discuss about the 5 different projects that we're going to talk about in this particular symposium today. Starting off with, we have Aditya and
Hello guys, I'm Aditya Zadav. I'm from India and we are here. We came in last August on 19th August and this is the first presentation that we are going to present in USA and we're pretty excited to do it.
Hello, everybody. My name is Dr. Apni Suniti Namdar, second year MBA student. Yes, here in 1 month and first presentation. Thank you.
Hello guys, I'm Kanishka Bhaskaran and I'm also in the College of Business and IT and this is my second year. Nice to meet you.
And, yeah. So till the slides are set up, we all here are for Mass Timber Project and we all know its uses and benefits and we are here to talk about its business aspect. But we were going to start with the introduction of Mass Timber.
So yeah, just to start off with what mass timber is, why mass timber, and what are the benefits of mass timber using in such a metropolitan area. The first and foremost benefit would be the carbon dioxide emissions that we talked about. Being a metropolitan and and being Detroit itself, the more automobile industry hub, you have a lot of cars going around, and that those carbon emissions coming out. So mass timber would be a definitely better option compared to concrete and steel because the consumption rates of mass timber is way higher. That gives you a better appeal at the same time a more environmental friendly approach to a metropolitan area like Detroit. Coming down to other points that makes mass timber better option is the labor quality and the efficiency of labor compared to steel and concrete. Steel and concrete because the amount of time that you require for construction on these two materials, mass timber cuts down that very efficiently and saving a lot of approximately 30 to 35% on your labor costs, which perfect. We have that. Uh, so yeah, that definitely improves your ROI over the end of the project. And We have the slides here, and you can go over. Go ahead to the third slide. Yeah. So yeah, overall, what we are trying to cover today in the topic is we have 5 different case projects that we're going to talk about. The residential building, industrial, mixed use, commercial, and educational buildings that we're going to be addressing today. Overall, what is green mass timber and how we can make it more efficient using solar panels, thermal panels and everything, insulation, and how we could make it more efficient in in the metropolitan area. Insurance, definitely a big topic that we're going to talk about. Labor costs and the speedy efficiency of that. And then ESG benefits along with tax benefits that the government gives you for using mass timber.
Since morning, I think mass timber will be the talk of the stage altogether. But why mass timber? Why not concrete and steel? So these are the bit evidences why to use for mass timber. Like there are 70 to 90% less waste than the traditional construction method. If you are constructing a building, there are a lot of waste which is not sustainable to the nature. So if you are using mass timber as the construction material, 70 to 90% waste can be reduced. And apart from that, 90% wood of the mass timbers comes from the sustainable managed forest. It's not like you're using timber products, it's a deforestation. It doesn't go that way. According to the source we got from Forest Product Association of Canada, they state that 90% of the 95% of the woods are come from a sustainable forest. And after that, carbon sequestration. Carbon sequestration, mass timber helps in that for more than 30% and more carbon sequestration has been done by the mass timber from the source of University of Oregon. Next, as Niti stated, there are 5 different typologies of building we are dealing with, and first is residential building. Before getting into the contents of the slide, how we expect our house to be, how we expect our residential to be. We expect a soft, comfy nature, some cozy environment in our house altogether. And mass timber gives a natural, warm, and aesthetic look to our residencies. And mass timber, since it's a renewable source, it has lower carbon footprint. And apart from that, wood gives the thermal insulation in around the residencies. That's why, and mass timber have another advantage that we can prefabricate the mass timber before getting into the actual construction site. We can prefabricate, we can pre-modelize that the way we want the mass timber before getting into the actual construction. So it by chance it will reduce the construction time too. This is the cost breakdown. We just assumed that 100,000 square feet residential building, and we did the cost breakdown. And from this ROI, from concrete and steel, we are getting 14.56% ROI, and from mass timber, we are getting 19.76% ROI. And from this graph, we can notice that drastic differences, the trend of mass timber compared to the concrete and steel. And the projective revenue we are getting from mass timber is around 200,000 difference comparatively to the buildings which we build using the concrete and steel. And this is the live example of a mass timber residential building. It's a Brooklyn mass timber house. It's located in New York. And next is industrial and transportation building. For industrial and transportation building, the major thing is the same advantage can be used like prefabricated mass timber products that can be reduce the construction time. And apart from that, it has a drastic difference of 200,000 projected revenue comparatively. And next slide. And these 3 are the live examples of industrial and transportation building application of mass timber. This is Chicago O'Hare Airport. Their satellite concourse Terminal 1, they just renovated using the mass timber. This is NIST building. They renovated the entire building using a mass timber. And this is the Portland International Airport. This is the world largest mass timber project as of now. And they just did 9-acre ceilings using the mass timber. And according to the airport authorities who worked on the project, they just mentioned that they used mass timber to increase reduce the stress of their passengers, to increase the eco-friendliness of their passengers. Because in airport, people may come and go in a different mood swings or different moods altogether, and their airport authorities feel that if they are constructing their environment using a mass timber, it will increase the sustainable nature in that among the passengers.
So as we all know that we are having a density population issue currently in all over world, and mixed timber use, mixed timber building is giving the new opportunity for everyone. This way, we are able to have commercial buildings on the lower level. We can have like arcades or any hotels or anything, and at the same time, a person is able to have like their own homes on the top level. At the same time, both residence and commercial spaces have been utilized in the urban space. At the same time, it reduces the carbon footprint, aligns with the green building standards of the city norms. Although initially it is a higher cost to invest because it is using both concrete as well as timber, which increases the building cost. But at the same time, on the longer, when you see a longer duration, the maintenance costs are lower and durability is also higher. The same, the ROI over this, the mass timber ROI is 20%, and because of concrete, it's just 14.5. At the same time, we able to see that the sustainable intensives are at very minimal cost. That's the best use of mixed timber.
So coming to the commercial buildings, those are definitely what we need at the Detroit metropolitan area because of increasing commercial and businesses around this place. Going to the ROI on the next slide, couple of points that I want to highlight is the design and engineering cost and land acquisition. We have assumed the same land acquisition for both concrete, steel, and timber, but as you can see, the design and engineering cost is a little higher because of the different types of mass timbers that we have. It can be CLT or regular mass timbers, and those are the bills of material that we're going to address. Is that increases the cost initially, but overall we save a lot in labor because of those flexibility and adjustable parts that we get in mass timbers, so that eventually reduces the price. But as we can see, and then sustainable incentives are also part of mass timber construction because the government gives you a lot of tax on using those, so that can definitely help in reducing the cost over a period of time. But initially, yes, the costs are definitely higher compared to concrete and steel. Overall, the ROI we can see as 20%, and then traditionally we get concrete and steel at 16%. So in a period of let's say 5 years, you can definitely gain a lot of better insights with mass timber. Some of the buildings that were constructed in Washington, D.C. and Baltimore using mass timbers for commercial places, there's examples of those. One of the slides that we also are going to address in the later is how employee retention can actually be increased using mass timbers, because you certainly don't want to be in a place where you don't feel welcomed or you don't feel the warmth of working. You don't want to be there, and then that increases your increase in the termination rate. And if you put a number to that, that eventually impacts the company. So if we use mass timber, then gives that warmth and welcoming feeling that employee wants. And over a period of time, you can see that employee retention rates, and that definitely helps in the companies increasing the ROI and then using mass timber as one of the products.
And in this slide, we just did an experiment like mass timber increases sustainability as we discussed before. But what if we use the green residential building completely made up of mass timbers, solar energies, rainwater harvesting, entire green? So what will be the changes it will make apart from the traditional mass timber, normal base mass timber projects we discussed before? And from that, we just found out that for residential building and rest of the data are same for the different criteria of typologies of buildings, but construction cost obviously it varies. And for construction cost, we just found more or less of same, but green mass buildings do have extra construction charge because we have to set up the solar panels, rainwater harvestings, and we have to connect the solar energies to the rest of the electricity purpose of the house. So initial construction cost will be high, and but the operation cost from operation we can save around 20 to 30% in the energy bills, and water bills we can change up to 50%. And And for maintenance, we can save up to 1 to 2%. And from this, if we are converting a residential building entire to green, we can save lot of cost apart from the traditional mass timber projects.
So yeah, coming to the big part of the project, that's insurance, and then definitely an important aspect that we want to consider because given mass timbers, it is the higher than steel and concrete because it's more flammable and you can easily have insurance related issues. So yeah, that increases your project cost drastically. But as mentioned earlier, like labor and then the flexibility of mass timber cuts it down to a lot of extent. So that there's labor composition that we have, and then we can see that how even though you get specialist and in general labor, the overall cost is less than these two combined. Speed and efficiency adds on to the labor itself. Like you have 20 to 30% faster construction times. You don't require that many skilled laborers, but at the same time, if you have skilled laborers, that definitely adds on to the construction and makes it more efficient.
So, coming to environmental benefits, as we all have presented, carbon sequestration is much more less in mass timber projects. Reduce carbon footprint by 50 to 70% as compared to steel and all other kinds of buildings. Sustainability resource use. There are many certifications that we need while building into Detroit region, and it gives added benefit while constructing. And you don't, when we are going for mass timber building, we don't have to pay keen attention onto that because it comes with our certifications. In social benefits, as my colleague mentioned, we have when we construct commercial buildings, employee retention increases because uh, onboarding process and exit process both are cost to the company, and there was this we can consider that how we can increase the employee retention, and it helps in building revenue in turn. In governance benefits, sustainability, timber production, life cycle analysis, construction regulation, incentivization, all have different types of certifications which we can get if we construct mass timber projects, and they are having benefits from governments and different certifications. And under tax benefit, we did some research and grant programs. Grant programs are of two types which they support, and approximately up to 50% you can get the grant for initial construction cost, which is considered. And in certifications, Forest Stewardship Council certification is one of the valid consideration. It has also two types for standard company evaluation and controlled wood standards for forest management. Coming to as we talked about green lead credit categories, if lead credit actually certifies that when a building, how much it emits, and under which category it comes. It has four types of certifications, and when we do mass timber buildings, they can come under gold and platinum. So in conclusion, I would like to mention, as we all know, the benefits of mass timber project. We all know initial costs are much higher, about 30% higher, but in overall, we do save in long term the cost, and we get premium rents which are 7% higher than normal buildings. So all in all, in consideration of future, we are even environment friendly, helping other generations to be there. We should definitely go for mass timber projects. Thank you.
Let's try yours. All right, so next up is Pat Layton. Pat is the director of Clemson, and I think probably all the experts in the room already know who you are. In case anyone doesn't know who Pat is, she's the director of Clemson Wood Utilization and Design Institute and a retired professor of forestry. She spent 14 of her 25 years at Clemson as director of the School of Agriculture, Forest, and Environmental Sciences, and chairing two departments, forest resources, and forestry and natural resources. Before joining Clemson University, she held various positions with the American Forest and Paper Association, Scott Paper Company, Oak Ridge National Laboratory. She serves on the board of Sustainable Forestry Initiative, is a native of South Carolina, and has forestry degrees from Clemson University, Texas A&M, and the University of Florida. Welcome, Pat.
Thank you. Well, we're gonna get there. But it's great to be here, so I'm gonna start with asking about you. First, I love the business presentation. I will tell you that the Andy Quattlebaum building, which you'll see, and you already shown us pictures of today, actually came out less in cost than the conventional build because we have exposed ceilings and they're all wood, and the wood ceilings saved us $100,000 in sheetrock costs. Nobody puts that little factor in there, but you do. I have to understand that. Okay, I'm going to try this. Plug it in again. Can y'all hear me without the speaker? Perfect. Okay, good, because I have one of those voices. How many of you been in a forest? Good. Was it an urban forest or a rural forest? Was it hardwood or softwood? Can y'all tell me? Hardwood. Where did you go to a forest at?
I'm an agriculture student, so I had a lot of projects in forest. So I have been to forest for a lot of them.
Good, wonderful. So, I'm a forester. Have you ever met a forester before? You have, good, you have. Okay, great. Not many people have. I am a raving environmentalist. I am not the kind of person who just goes out and destroys foresters. And none of the foresters that I know do that. Why? It's not in our interest. It's not what we like. It's not what we do. We're about growing trees and managing forests and ensuring that there are forests for the future. No sawmill, no pulp mill, no mill is going to invest $1 billion in a company to put a plant somewhere and then go cut all the trees down and not have any wood for the next 100 when they finish cutting them. It just doesn't make business sense, and that's not what we do. So I want you to understand that we think we're the green material because we have a renewable product that we can regrow and reuse and all of the benefits you saw here, and we're just going to keep going.
Do you have any way to give me the presentation?
I don't know, but I was going to say, is it a screen choice thing? Display settings. Let me pull this up. So I'm selecting LG TV, use as main display. Let's see if that works. Yeah. Give me a second. Mirror for LGTV. Okay, so wood buildings are not new. Some of you are from India. Do you know how old your oldest buildings are? And were any of them from wood?
Yeah.
Okay, how old?
2000 years.
2,000 years. So in 2019, I went to China, and I got to explore, yay, there we are. I got to explore buildings that were very old, 800 or 1,000 years old, and they were wooden, and they were very tall. And so they have been around for a long time. This is my campus. You've all seen the Andy Quattlebaum picture. That was our first mass timber building on campus. First wooden building we built in many years. Because this is a wooden building and it was built in 1896. they're large, probably they were built out of wood. Because when did concrete get invented, y'all?
The original concrete? Like
Not the original, not Rome. That's not concrete as we know it today. In the early 1900s. So what were we building big buildings with out of before that? And guess what? Steel wasn't that big either. Because how many architects know when we weren't building big buildings out of steel because we didn't have the Eiffel Tower. One of my favorite architects talks about the Eiffel Tower moment. It changed us from building skyscrapers of wood to wood buildings that, so this is one of the temples in China. This is the Bradbury Building. This was one of the first high-rise wood buildings, and it was built around the turn of the century. Then we have the Eiffel Tower, and everybody goes berserk. And what I want to tell you is that today our opportunity exists for the timber industry to grow and be a part of the nation's economy and also to support forest health. We are, yesterday, I am, as working in forestry, I am celebrating a 0.5% cost cutting by the Fed. The 0.5% that went down. Why? Because we can build houses again, hopefully. We will have mortgage rates. Because we have sawmills closing down every day. They're losing $500,000 a month because there's no housing industry right now. We desperately need to start using wood. And my summer has been spent watching southern pine beetle invade my forest because I can't cut them. There's no market for it. This is on our campus. I mean, I can see a huge insect population growing. We need to cut that. There's no place to put the wood. There's no market for the wood. It's really, really sad. And it's a forest health issue. So markets are part of managing forest health. Now, I've given you the forest, the timberlands of the U.S. Now, we are, in the U.S., the world's third largest wood basket. We produce more wood than almost anywhere else in the world other than the former Soviet Union or the Russian Federation and Canada. But just the South alone is the third largest wood basket. So when you add the South and the Northwest and the Northeast and the Lake States, it still stays the third. But just this alone, that's how much wood we have here. And we are growing more every day. In my state, one of the guys did a thing, and on 25% of our land base alone, we are growing 16 cubic feet of wood per second. That's 25% of the wood base. We have about 12.9 million acres, so roughly 3 million acres or so. It grows 16 cubic foot a second. That's a beam 16 foot long, 1 foot wide, and 1 foot, 1 foot on each side. So think of that beam. That's a lot of wood. And we can't use that wood. We are so seriously affected by things. So here are how the wood, so you saw this. This is where the structural lumber industry is. Structural lumber here, amounts over here. Western California, they're still trying to hang on. We need these mills because California needs to thin their forest to reduce fire. They need to reduce fire for reductions in fire out here. We need this industry. But if nobody's using wood, there's no reason to cut that wood. It's growing and growing, and the fire conditions get worse. The insects and disease get worse, and we are battling this constantly. So we got into the business of doing our work at Clemson in 2010, just as the housing crisis of that time, the mortgage crisis of that time happened. And we were talking about collaborative. We started with architecture and engineering and forestry. Those were the three groups that got involved and said, we got to do something. We need more than housing. Because housing is the dog. We are a gnat on the dog if we go into commercial and non-residential buildings or multifamily residential buildings. At that time, we were just getting building codes that allowed you to go multifamily. some of these things, and everybody wanted to know, do we have enough wood? Let me show you what the South used to look like. This is cotton farming, where I live right now, and there was not a tree in sight. It was cotton fields up to one side of the house and out the other side of the house, and I lived in a Piedmont area of South Carolina. It was eroded soil. Thank God for the Roosevelt administration and some programs that came along that helped us restore and recover all of this ag land and put it back in the forest. Because it was forest. It had been forest. It had been a well-managed forest by thousands of years of people who inhabited this land before Western Europeans arrived and started cutting down trees and growing crops. So, this is what it looked like when we got it going again and got trees planted. This is what it looks like today. Most people who walk in that forest would never know that it had been barren ground and farmed for 150 to 200 years before we reestablished that forest. And that exists across the South and the Northeast and the Lake States. That is not just here. Now, out west, yes, a lot of those forests are still natural forests that were there first because no one had cut them down because we didn't start settling that part of the world until the late 1800s, and we just never got the settlement there, and the agriculture was not developed there, that they had to cut down all of their forests. Although the valleys were cut, and ag is there, but so much of theirs is on a mountain, so it changed the differences in how we did it. These are historic glimpses of forestry from the Northeast, all over. This is Wisconsin. This is probably Maine. They are getting these logs cut. They're going to put them in a river and move them down the river and into a sawmill. Here's more wood going into a log. This is waiting for the ice to thaw. So we used to have to work with Mother Nature more. We can do things differently. And in a lot of cases, those weren't foresters, because forestry really didn't start in the United States until the first school at Yale in 1904. So these were just people, they were loggers. It was cut, and then people will come in and live and grow crops or whatever. But these are the things that were going on. This was not what I would call sustainable forestry at all. This is what the landscape in Colorado looked like prior to civilization kind of coming in. And the Forest Service saying we're not going to let fires burn. This is Cheeseman Lake area, and it was a very widely spaced forest. When we stop fire and prescribe fire, we end up with something that looks like this. That should not have that many trees growing on it. This is a Rocky Mountain forest. That's way too many trees. It needed to have fire going through it. So really understanding how we grow forests, how we manage forests, what the role of fire is, how many trees can grow on an acre. Because I can grow 1,000 trees on an acre, not very healthily, and some of them are going to die constantly. There's going to be dying out there. I can start with 1,000, but you know, even in where I live today, we really only, when we get to when the trees are mature, we really only have about 250 trees on an acre. We don't have 1,000 trees on an acre like that. That's not healthy. It burns. Fire comes on, wipes it out, massive wildfires. It has to get reestablished. So as we moved across the country, as the population grew, I just want to get to this. Here's the population changing. The forest, amount of forest changes because down, and finally we're coming back up. Why? Because we had to have food and we had to have buildings. And guess what railroads require? At that time, they required wood and water. Wood for bridges, wood for tracks, wood to run the engine, water for the steam, and things happened, and you had to clear out as you built railroad tracks. You had to clear out before diesel came along, before we had electric trains and other things. You got to always think about all of these things. And there is the environmental movement of the 1800s was really impactful and really changing the way the world looks, because it looks a lot different today today than it did back then. I would have been appalled as a forester to see this. Now, most people don't think of foresters as being very pro-art. I'm going to tell you I'm pro-art because the Hudson River School of Art showed clear cuts in their ugliest in the 1800s to the most beautiful inspiration of nature. This is Thomas Moran's like one of my faves. And it motivated people. It's that sense of where we are and what we can do. And so it started that movement of let's bring back or protect the forest we have, which gave us the Forest Service, and then gave us Roosevelt, both of the Roosevelts. And the work that they did to promote conservation and forest management and getting land out of ag when we didn't need it to grow food anymore because we could grow food on smaller plots of land, and we did this. And so these are connections. So when we talk about collaboration, to me, the ultimate collaboration was the impact of this art on conservation in our country in the 1800s, the late 1800s. They're directly linked. Those pictures were in areas where people made decisions. They got to see those pictures. They were impacted by those paintings. They traveled around. People talked about them. There was a wonderful dialogue about what we needed to do, and we were able to do it. Now, the other thing about the 1800s is that we had vast fires. And in fact, there is a series, like the Great Michigan Fire, was a series of simultaneously forest fires in the state of Michigan, 281 million acres. And there's one, like we had 300 million acres here. And as I understand it, the Great Chicago Fire and the Tuskegee Fire of 1871, everybody knows the Chicago Fire, those were the same day, same week. Why? We were in a La Nina weather pattern, which meant that, and we'd been in it for like a year, and it was very dry and lots of wind coming, and it was just a spark ready to happen. 2 years ago, Oregon, we were in a La Nina pattern, and we had massive wildfires in Oregon. Understanding that climate and these big global things are going on impacts us, but these also impacted how we manage forests and grow forests. So lots of things going on. Now, as a result of all of this, who owns the forest? People like me. I have 2 acres, but the back of my house is all forested. Got great big beautiful hardwood trees in mine. But then I have friends who own 15,000 acres of forest because their family bought land and planted trees or grew trees, and they accumulated. I know there are industries like Weyerhaeuser, the real estate investment trust. They have 13 million acres of forest. Forest Service, BLM, Park Service, all of those federal ownerships are only 30% of the forest land in the United States. 10% is state and local. Minnesota has a lot of county forests and school forests and things like that. Private owned 60%. The average size of that acreage is about 20 acres. But most of those people and that 20-acre people never get into the forest product market. Why? Because it's just not economical to cut anything that's less than 50 acres. So I'm just going to tell you, the vast majority of forests are never going to be harvested. It just doesn't make economic sense. Now, the South is private. The Northeast is private. The Pacific is where most of the federal land base is. And they sometimes can't harvest because someone in Vermont files a suit against somebody in California, and the Forest Service is stopped from harvesting. Not always easy. In our country, you can find out a lot of information by going to the National Association of State Foresters website, stateforesters.org, and you can choose any state and find out a lot of information about that state, what kind of forest it grows, what the ownership is, what the size are, what the species are. And I encourage you to do that because every state is different and they have different forests and different worlds. And the people who work for these organizations are more than happy to help you learn about forests. They are incredibly opportunistic to tell you because they want to show off what they're doing. They want you to use their products. Keep going. So a lot of people are like, okay, so there's private management. So there's two kinds of private management. What I call private corporate. This is retirement people's funds. This is a timber industry management organization. So they invest people's retirement funds and they grow. This is a young forest. It's only about 14 years old. It's already been thinned. This is the result of that thinning. And that detritus that's left on the ground is habitat for insects and rodents and all kinds of things. But it's growing back very quickly. Now, I have a friend. He was National Tree Farmer of the Year one time, and this is his forest. This is the same tree. Probably started out looking the same, but he's managed it longer. It's an older forest. He burns it frequently, like every 3 years he runs a fire through it. Why does he run the fire through it? Because when in the southeast, when we run fire through it, we come up with probably the most diverse ecosystem in the U.S. Not in the world. There are some other rainforest type things where it's very diverse. But it's not the trees that are diverse. It's everything from here down. Thousands of plants and animals and fungi and insects and all kinds of things that live in that below story world. An amazing thing. I don't want to stack it in trees all the time. And I want that opening to move because different animals and different plants need different kinds of habitat. And so we'd love to see that management move around so we have closed and we have open and we're getting water and we're getting great air and we're getting all of those ecosystem services off of that. What I as a forester look at is green junk where nobody touches it and nobody manages it. Nobody thinks about it. But when I do those management things and I have the opportunity to help and to have a market for that wood, it allows me to practice sustainable forestry. Now, the business group mentioned FSC. There's a group here in America called Tree Farm. They do a great job of reviewing people's forest practices. The other one that's out there you may have heard of is the Sustainable Forestry Initiative. And I'm going to tell you, I am on their board. I'm the vice chairman of their board of directors. So I'll just say that in all honesty. I helped invent that system years ago when I was a much younger forester, back in 1994-ish. We came up with that project. It wasn't audited back then. Today, it's a fully audited system. And you can even they have a standard now for even urban trees and urban communities, our campuses. So I hope that this year my campus becomes the first campus that is certified to an urban and community forest standard because we believe that hands-on, if you're using a forest, can't be hands-on, be intentional. Get it managed and manage it right and do it sustainably. So those are important pieces. Fire is an important record. I wish we had more fire in our country because most of the evolution of our trees over time, especially probably pre-glaciation and post-glaciation, fire was a dominant piece of our landscape. And so a lot of our species evolved under that. They respond very well with fire. And so we would love to see that return. In fact, fire was banned from California. It was a native tradition to use fire to manage timber and places in California. It was banned in 1928. South Carolina, we had a lot of prescribed fire use by Native Americans and banned by the Forest Service. Saw timber availability. We are growing, as of 2014, this number has gotten bigger, 3.4% more wood annually than we are cutting ever. That's not about cutting. Sorry, it's not about cutting. For every acre of tree, we're growing 3.4% more annually growth on those stands too many. So we have more and more wood every day, and this number has only gone up. So we got plenty of wood. I'm going to show you what happens when a hurricane comes through, because we all are susceptible to problems like hurricanes and forest fires. This column of wood right here was originally started in 1980 and 1990. 1989 in August or September, Hurricane Hugo came through and took out a large segment of forest in South Carolina. I can trace this amount of wood, this availability, this acreage of southern yellow pine forest type to this time frame around or right after Hurricane Hugo. Now, this was a long time ago when we did this. This has just gotten older because you know what? We're not using enough wood to even bring this down. Because I'd rather have, if I were really a good forester, I'd have about the same amount of trees or acreage in every age class. But sometimes we get these problems like hurricanes or wildfires, and we have to restart our forest, and it kind of messes up. So forest markets are essential for healthy forests. Mass timber is not a silver bullet for all of this, and it is not the only thing we got in our tool belt. You know, you can use wood for a lot of things. You can use wood. Pulp and paper are good products to use. Keep going. We need all the pulp and paper because when I cut down a tree, I'm going to use the bottom of it. I might make veneer out of it, which I can do here. You can see it. Or I might make if I may use it for saw timber boards, which I then turn into CLT or glue lamp, like the first group talked about. But the top of the tree, if it gets above, about 10 inches, where it's 10 inches or smaller, am I going to just leave it laying in the wood? No, I take that to a pulp and paper mill, and the landowner gets more income for what they run. So to me, utilizing every inch of available wood that I can get into a marketplace gives more money back to those landowners. Because I don't want to put $190, $290 into establishing a forest, and 30 years later get nothing for half the wood that comes off of it. I want to get as much as I can because I put my money in that investment. So I think about these things to look at. I want to use every inch of what I can and then leave part of it there for wildlife habitat and restoration of nutrients back into the soil that they degrade over time. All of those kinds of things are very important. How much time? Oh, I got 6 minutes. So I want to talk a little bit more about mass timber, though. Mass timber is, people will tell you, it's going to do this. Kind of watch it. I'm just going to tell you. Because what it does, frankly, is it does require, and I'm talking about CLT and glue lamp, it does require very good wood. It requires, in general, we in the U.S. don't make CLT out of 1x1s. They might in Canada, but not here. We make CLT out of things that are 2x6s and 2x4s. So a 2x6, to get a 2x6 cut out of a log, you've got to pretty much have about 10 inches or more of wood around it to cut it out. And if we go to 2x8s or 2x10s or 2x12s, we've got to have even bigger trees. And we also have strength requirements. And by the way, there are structural standards, lumber standards that are governed under ANSI and through the government system of what can you call a grade 2 or better. So prime is a beautiful piece of wood, no knots, because wood breaks at knots. Knots are not good. I hate knots when I want to make pretty strong wood. I'm going to have an increased number of pieces of wood that's going to use grade 2 and better. About 60% of the production of a sawmill is going to be grade 2 or better. Now, if I use a lot of glue lamp, you're going to build post and beamy looking things. Only about 6% of the wood that comes out of a sawmill is high enough strength and quality to make glue lamp. So if you use lots of glue, and by the way, glue lamp wood, so the wood that goes in the glue lamp, costs twice as much And glulam wood was selling for over $900 a thousand. So if you use a lot of glulam in your buildings when you're designing, you're jacking that cost up because they got to pay for it because it's a rare commodity. But if I use more CLT walls, I can hold up the same amount with a CLT wall and not have such a high price wood in it. But everybody likes that open wood. So think about your designs and think about the wood you're using. And oh, by the way, when you talk about these very open, long spans, come on, that costs money. And it costs higher E values, structural engineer. Yes, I gotta have better wood, not just a number 2 wood. I gotta have better wood in the CLT or the glulam, even better and better wood to make it happen. So you are raising the cost. So you have to think about your design in terms of what materials am I putting in them and what are they going to cost. And I would tell you the same thing about concrete and steel, because not every steel is equal and not every piece of concrete is equal. So you've got to think about that. You may be used to thinking about that if you're a designer, but now you have to think about it with wood and you're not as familiar with that. But guess what? There are marketplaces that will tell you the price of all these things all the time. You just got to look for them. Call that state forester's office. He'll tell you what it's selling for. And it's an important piece. So I want you to think about those when you make the design. Go try to do what you can. Yes, trees sequester carbon, and there's benefits. Now I'm going to show you this. This came from a tweet I saw in Europe. Came out of, to me, I thought, from a guy who was tweeting something out of Scotland, and he said the tweet was, "This is not a forest." And I'm like, well, it looks like a forest near me, and you just didn't wait for it to grow up. That was a teenage forest. Let me tell you, teenagers are not pretty. I was an awkward, ugly teenager. You know, I think I look better at 70 than I did at 14. You know, acting, you know what it's like. So really, you just gotta wait to grow up. Babies are really cute. Little forests are really cute. They're sort of like us. We live about the same age, you know. But this forest is probably about my age. Very diverse. This is a longleaf pine, which is a type of southern yellow pine forest. A lot of fire goes through here. But it could have started just like that. But it takes time to grow it and get it there. Just like we grow and change. So we have even age forest management, we have uneven age forest management, we have standards of how to do this. Yes, there are building codes, and I would say while everybody's talking type 4, most of the buildings that are being built today are type 3 wood mass timber buildings. Don't worry about it, you can get it there. And oh, by the way, you'll hear Nate talk later today, and I'm sure he's going to tell you, I don't even have to do that, I can go alternative means. So I can work, and especially in Milwaukee, thank you, fire, building code official who is a forest landowner. Y'all were so lucky. The building person there loves forestry, so it really helps them. Education of your building code officials are really important. That's why Washington, D.C. loves 80M Street. They educated their building code officials. This is like the best thing to happen to D.C. because not everybody can add 2 stories on the buildings all over Washington, D.C. without having to pay an extra dime for land. Because you all told me what the price of land was. That was your biggest expense. If I can add 2 stories of mass timber onto a building and not have to buy land or tear down a building, do the math. It's like ROI through the roof. And oh, by the way, they lease the area. Wood basket. So here's the secret. When we cut down a tree, we don't haul it more than 50 miles. That's it. That's all we haul. Why? Because trees are full of water, and it doesn't help you to do that. So I'm just showing you 2 states, Washington and South Carolina. We have areas where sawmills exist. Nothing is being cut out here. Maybe 50 miles around Yakima, and oh, by the way, one of those is the Yakima Indian Nation. You know, you got a lot here, but you just don't have a lot anywhere else. So that's a timber shed. This is a timber shed. Or we call them different things. By the by the way, just let me tell you. Foresters in the West do not speak the same language as foresters in the South. Maybe even foresters in the North, but I know foresters in the North, and I don't have any trouble understanding them, but in the South I do. So these are sort of the economics of the system. So here I cut one segment, and I cut saw log, I cut chip and saw, and I cut pulpwood, all from the same tree. I have 3 different products, and I'm left the very tip tops of the limbs out there to be degrading and returning nutrients and being habitat. These are really, I'm going to get on very long. This is utility poles. Poles are very expensive. High quality wood, very expensive, very straight, makes a good thing. But again, we're cutting them within about 50 to 70 miles of every sawmill. And then everybody's, oh, you're cutting the big wood. Well, let me tell you, there's not a sawmill around that's going to cut big wood. There's nobody out there. We've all gone to very high commodity, very efficient sawing systems, and most mills will not cut anything bigger in diameter than 26 inches. And that's east, west, south, north, wherever. There are a few hardwood mills I can get bigger things in, and there's a few old bandsaw mills where they have one line, very slow, very inefficient, that will cut bigger stuff. But they're rare. We are not cutting big wood. We can't. There's nothing in it for us. So fewer than 10% in the Southeast, 8% in the Pacific Northwoods, and size matters to the efficiency of these mills. We grade and we sort, we run through a lot of systems within sawmills. This is green wood that's come off a saw, it's getting stacked, it's going to get dry. And by the way, when I'm drying, not every sawmill is going to want to dry to the level that as a CLT manufacturer or a glulam manufacturer that I want it dry. Because they are only required to dry it to 17%, 19, kiln dry, 19% moisture content. But as a CLT or glulam manufacturer, I'd rather have it at 10 or 12%. And in fact, our manufacturing standard requires us to be below 14, 12 plus or minus 3, 15, so 10 to 15, 9 to 15. So I can't even go buy from every sawmill because they aren't going to produce wood that's dry enough. And the glulam is going to be a little bit drier than the CLT wood. Why? Because that's how we get, when the wood gets drier, we can get adhesive into the wood. Because the wood, when we glue it, is not like gluing glass on glass. It's not glue that just binds together at a surface. We want the glue to go into the wood. So in my engineering group, when we break a product, I better see wood rip. Because the glue had better not let go. The glues are stronger than the wood. So that's what I want. I want that glue to go down in and the adhesives and all this kind of stuff, so way down in the wood. I also want you to know that when you go to Lowe's or Home Depot or the local building code, every stick of wood in America has to come out with a key on it, with a code on it. That tells us what kind of wood it is, what level or what grade it is, how if it was treated, heat treated, and then right here, number 4, that's a mill identification number. So if you know a mill identification number, you can find where that mill is, and by the way, then you know that within 50 miles of that mill is most likely where the wood came from. So if you want to know where it came from, you go pick it out on the map and draw a circle, 50 miles. You know where it is. Now, CLT and glulam gets that planed off before we make it into CLT and glulam, so you won't see it on that. But if you're just buying boards, you're going to do it. Here's Douglas fir, just an example, same thing. And mill is 12. The mill ID is in that upper right corner there. So there's even an easy online source from the American Wood Council where you can go enter your mill grade stamp number or region to see the sourcing data and forestry facts from that region. So you will know kind of where you got your wood from. And again, we're talking structural wood. So most hardwoods are not structural woods. They don't have the grading system and the testing distribution center to building suppliers as in commodity glue in, but in a lot of mass, and that goes into light frame wood construction, and this is a lot of wood, y'all. And it's a great building material, and it's very inexpensive. But you can combine that one with mass timber. You can do the floors with mass timber and do the walls with light frame. I have a pool house at my house that's exactly that we're building right now. Again, light frame construction is code compliant. It is a little sensitive to fire and during the construction phase, but we know how to control those kinds of things. But here's what I want you to think, and I'm glad to hear there was an interior design person in that first group. I don't want you to think about just the structure. I want you to think about the view. I don't want to see I don't like being in precast concrete steel kind of structures that are so cold. Warm it up. So even if you're not building your structure out of it, if somebody does want to do this, put wood in it. Put wood everywhere you can. In the furniture, in the ceilings, on the stairway, you name it. Put wood in it. Use it as flooring, as a feature wall, as a ceiling, as a trim. And guess what? You can even do that for leaves. You should take wood from the local area. You cut down a tree, put it back in the building. That's the requirement. So think about what you're doing. Utilize urban wood. Utilize all the urban wood. Because I can tell you there are thousands of trees being cut in cities. And for, guess what? Development. The biggest deforestation in America? Development. So utilize it. I don't want to burn it. I don't want to see it piled in there. Interstate highways. My next worst enemies for us. Because they clear so much every time they cut this. So utilize that wood. Durability. Everybody's got wood's gonna rot. Wood's gonna burn. Wood is very fire resistant. So does anybody know the difference between combustibility and fire resistance? Nobody? What's combustible? It can't ignite. And what is fire resistance? It can maintain load carrying capacity. Steel only has to heat up to about 600 degrees something, Fahrenheit or Celsius, one way or the other, to actually, and it will lose its load carrying capacity. Wood is only going to char when it gets heated up, and it will only char at a rate of about an inch and a half an hour. And the way we design and build with wood, we overbuild and overdesign such that we have a 2-hour or 3-hour fire load because we just put bigger and bigger chunks of wood around it. That's fire resistant. It will stand up. And I've seen and talked to firemen who said, I would not have gone into this building if it were steel, but I would go into it if it was wood because I know the floors are going to hold me. So you've got to think about these things. So there's a big difference. Wood is fire resistant. Concrete and steel are not fire resistant. Let me tell you about a bridge in Atlanta. Went down in a heartbeat because some PVC pipe underneath it got started on fire. And it went down like that. It's not fire resistant. So biophilic design, that got mentioned. Biophilic design, I'm so sorry, is really important. Because you can take any building today and make it. Because the most sustainable building is a building we don't tear down. But when we redo that building, we need to be thinking about how can I make it more biophilic? Because people do feel better in a building with wood and natural materials. So as you think about renovation or redoing or adding on, I want you to put that in your mind and think about how you bring that into your design. It doesn't have to be structural. It can be interiors. It can be the features you put in your building. You can make a building a better value for leasing or having people feel comfortable in or being less stressed in simply by all of the design choices that you work with. It's not just about structure. Structure's great. But I want you to think about all those other wood pieces. And oh, by the way, know that not all wood is equal. That's the other question. Well, know what? Wood is not equal. I can't use some woods for certain things. Like I'll tell you, ponderosa pine from out on the Yakama Indian Reservation makes the best doors. Why? Because it doesn't shrink and swell very much. It's a very stable product. It's not. You're not going to get stuck if you're using that. Yellow pine, put it in the door because it shrinks and swells. So it's going to stick. So when we know characteristics of wood, like I love sapele. It's like exotic, but I love it. It's so pretty. You know, mahogany, if it's grown well, if it's managed sustainably, really gorgeous, really brings the elements. I'm a native wood person, but you know, there's nothing better than white oak for that bourbon barrel or wine barrel that has its purpose. Great product. Let's keep using it. So that's what I want you to think about, is thinking about the wood, thinking about what you can do, and to know that well-managed forests depend on good designs and maintenance, and we'll get sustainable and durable buildings. So I'm going to shut up because I'm way over. I'm so sorry.
See if we get how to do with this. Next up is the last student group in this chunk this morning, and you guys have been looking at industrial systems, right?
Yeah, industrial.
Alright, you guys want to use the mic?
No, I think. Yeah. Alright. Hey, can you guys yours okay from the back?
Yep.
Good? Alright, okay. No
You
mic.
just have to keep doing it.
Yeah, I'll work it. That sounds really good. Alright, so my name is Alberto. I'm Carlos Loya. And I'm Kobe Miller. And then we're all senior architecture students at Lawrence Technological University. We'll be presenting to you guys about mass timber and the industrial participation built the college. Alright, so just to begin, just a little overview again. We kind of saw this with the first group, but what is mass timber? So mass timber is just engineered wood products that are normally like either beams, columns, or panels that are used structurally in construction. The main products that we really looked at, kind of the ones that are used the most are CLTs, glulam, NOC, CLT, and then MGP. For CLT and also other sorts of the regular ply options that they offer is between 3, 5, 7, or 9 ply. So just a little brief history. So actually, mass timber was really prominent in Europe, kind of in the late 1900s. So like in 1985, that's when France first patented the first CLT. But it wasn't not till like the 2010s that it actually made its way over to the U.S. and not till 2015 when CLT was actually recognized in the building code. So just talking about what's happening with mass timber here in Michigan. So the first mass timber building that we have in the state was actually MSU STEM facility, which was built in 2021. This building it's all just a mass timber structure on the inside. Unfortunately, they didn't leave anything exposed on the outside to kind of emphasize that. And then MSU is also still researching mass timber, more looking at softwoods as well, just to kind of be able to kind of push the use of this product more in the state and in other states as well as Michigan Tech. They're looking more at hardwoods since that is what we have the most here in Michigan. So like I said, we are the industrial and transportation typology. So just a little kind of brief requirements that we might need for this typologies is normally open floor plates are kind of preferred, as well as larger spans to kind of not have any obstructions of columns or anything within the floor plan. So as of now, all the precedents that we kind of looked at and most of the buildings of these typology use mass timber normally just for like roof, beams, and wall components, not really columns as much. So for that, so it's gonna counter that. So they use a hybrid structure. They either bring in concrete or steel to kind of help achieve those larger spans and open floor plates. So just looking, so this is just the
full United States. Here we kind of just highlighted where these industrial or transportation buildings are either built or under construction. And then in relation to kind of where some of those mass timber manufacturers are actually located. So as you can see, they're all within a few hundred miles from each manufacturer. So a question that we kind of asked ourselves as we were going through this research was, is mass timber a viable alternative to traditional materials for industrial and transportation buildings? And after we completed our research, we came up with the answer and it was yes. So there's a lot of benefits that mass timber actually can provide, and these include economical, sustainability, and health benefits, which we'll be touching on. So looking at the manufacturer that we chose, so for the main one, we looked at Prayers Wood. So instead of like looking at glulam or CLT products, they actually do mostly MPP or MPL. So MPP panels are normally used for roof, walls, and floor systems. So they're made out of 1/8" veneer, which is then glued together. And then MPL is normally it's still wood veneer, but it's kind of made to simulate more column and beam like products. The main species that they focus on are Douglas fir and hemlock, and kind of the main building typologies that they really worked or have worked with is like sports and recreation centers, educational, food transportation buildings, and also residential. So kind of this is just a building that they actually worked with. We kind of saw this in one of the earlier presentations. So the Portland International Airport first actually provided all the mass plywood panels that made up this 9-acre roof. They actually had to divide this roof into 18 different sections to be able to transport it on site, but this allowed them to not only keep that terminal still operational while they were constructing it, but it also reduced the construction time quite a bit.
So then we go into the second manufacturer that we looked on, and it was Structure Craft. We particularly chose this manufacturer for the custom products that they offer. They work one-to-one with the designer or the architecture firm, and they are known for DLT and glulam materials. But something really cool is that their engineer is working with the team from day one. So any questions you may have, they'll be able to answer and provide advice for it. So a cool precedent that they worked on was the KFC Aerospace Center in British Columbia, Canada. It's by Michael John Architects. Something really particular about this is the owner of this specific building goes, I want something that looks like an airplane. So as you can see on the left picture, right picture on the screen is that the really tall span is made out of hybrid glulam beams, and then they have steel rods at the bottom for the tension forces. And then probably the most characteristic interior piece is the spiral staircase. It's all made out of CLT, which is curved CLT. It's made out of 2 pieces. Overall, the wood itself weighs 1 ton, and it's a concrete and timber composite. So this specific staircase by Structure Craft, they had to do a lot of testing for it. It was never done before for something this big. So they looked at what the twisting forces would have been for hemlock fir, and then also how transportation could actually be achieved for it to arrive to British Columbia. For this, they actually did some jigsaw puzzles for it to fit in the flatbed, and then overall, the staircase itself won the 2023 Outstanding Structure Award by SCCE. And then looking at the codes, like they said, it's not something that's been here for a long time. It's new. So having someone on the board, like our previous presenter had said, is honestly really nice. The safety assurance, people think wood is flammable. It isn't. It's actually a lot really fire resistant. And then just overall, it's community awareness that would be able to bring this code back in track and then actually be able to use it in industrial and transportation buildings. So how could it actually help an industrial transportation building? It's very simple since the MEP system layout is fairly open. It could be exposed as there's not many clients that would want it to be hidden. And it sets a really strong foundation for, as we said, with project and an overall operation. And then something that people normally talk about with transportation is the last mile delivery. So making this prefabricated, really big products, make it onto the site. For example, here we are in Detroit, we have a lot of buildings nearby. So bringing a crane in for the product to be installed might be a little bit of a challenge, but being mindful from the beginning of construction and design, making sure that it's able to be delivered somewhere is probably one of the most important pieces of mass timber.
All right, so I'm just gonna touch on some of more of the sustainability benefits that mass timber can offer. So, embodied carbon. So mass timber, as we know, trees as they grow, they store carbon inside, and actually once they're cut down and turned into these products, that carbon still remains stored within the mass timber products. Um, they can actually reduce emissions of CO2 from anywhere from 13 to 26%, and they actually can help promote healthy forest management. Like our previous presenter said, it's not the only option, but obviously this can also help get that started, as we know wildfires are a problem, and being able to cut down more trees will help with that. Um, just a quick little life cycle analysis, so just showing kind of the circularity of mass timber. So after this, uh, these materials are used and everything, and the building comes to its end stage, this material can be either reused or recycled, which can actually help lower waste overall in the end. This just shows some like biogenic carbon flows. So it just kind of shows that mass timber can actually help achieve a net zero carbon emission. So once it's harvested all the way to the end, if it's reused, recycled, or incinerated, that kind of biogenic carbon flow would kind of even out to zero. However, if it's not, you know, reused, recycled, or incinerated and just left in a landfill, that carbon will still be stored in those products until eventually they degrade. So just looking again at the Portland International Airport, they said really good sustainability when it came to where the wood was sourced from and how it was transported to the site. So all of the wood used for the beams and also that 9-acre roof was sourced within a 300-mile radius. And you can see in this map kind of all of those kind of areas where it was harvested, the mills that it was taken to, where the actual products were fabricated, and then PDX right there in the middle of all of it. This helped reduce the carbon footprint by 70%, and it also helped them achieve 125% savings in embodied carbon just from that roof structure alone.
So now I'm going to get into some of the user health and wellness aspects of mass timber. So they've actually been doing a lot of experiments on this recently, and exposed wood has been shown to increase user health and wellness. It increases productivity, creativity, and concentration, while also decreasing stress, anxiety, and depression. Mass timber, as many presenters before us have said, promotes biophilic design, which engages users uh, to nature while inside the building. And the University of Oregon actually recently did a study that found that a lack of connection to nature and poor architectural design could be attributed to 10% of employee absences. So for this, we're going to look at a precedent, which is the University of Arkansas Library Storage Facility, designed by MBL Architects. So this was built in 2018. It is actually construction type 5. The entire structure of the building is made from mass timber. The original plan was to do it in a steel and concrete composite structure, but they later changed to this mass timber, and they estimated by the budgets and stuff that they had in place for the steel and concrete building that they saved a $1.1 million by switching to the mass timber. All wood on the inside is completely exposed, which allows users again inside the building to connect with nature a little bit in what would otherwise be a pretty closed off area. Now diving into the quality impact of mass timber. So as we've mentioned before, there's benefits in sustainability, construction times, labor costs, indoor air quality, and acoustics. So there's a 30% decrease in construction time when comparing mass timber to concrete and steel. Its porosity and density make natural wood absorb more sound than steel and concrete. This could be also affected by the finishes that are applied on wood. So if there's any stains or clear coating that are added, it might decrease the wood's ability to absorb the sound. And again, it promotes biophilic design through daylighting techniques and exposed natural materials. So for this, we're going to look at the Nanotronic Smart Lab, which was built in Brooklyn, New York by Rogers Partners. So the original building was actually built in 1865 to manufacture ships, but they did a remodel of it in 2022. The shell is not mass timber; it's actually a light frame construction for the walls, and then they uses steel trusses and concrete columns in the middle. So they did not touch the shell at all. Basically, all they did was a interior remodel of this building. So all these interior pods that you see here in the picture were constructed in just 28 days which is kind of a ode to the timeline benefits that we see with mass timber buildings. And all the timber that is in this actually holds 411.2 metric tons of CO2, which the average person globally produces about 4 metric tons of CO2 in their lifetime. So that's over 400 people's combined CO2 emissions in just one building. And so some of the design elements that we see in mass timber, a lot of times the exposed structural elements are a key design aspect in these buildings. Again, it's centered around biophilic design, and natural light is a recurring theme, uh, recurring design element in these buildings. And then, as I mentioned before, wood stains and finishes can be used, as well as charring, which this is actually the outside of that Arkansas library facility. It uses a charred wood cladding, which is there's a detailed picture of that on the right there. When it comes to vibrations, acoustics, tactility, and durability of mass timber, again, a lot of people think that a steel and concrete building would actually be stronger than a mass timber building. But UC San Diego did a shake test on a 10-story mass timber building. The building withstood a 7.7 magnitude earthquake with no visible damage. This magnitude of earthquake has caused a lot of concrete and steel buildings to crumble, and yet this building again withstood it. Some of the key takeaways that we discovered while we were doing our research was that mass timber is more sustainable than concrete and steel. It saves money in the construction phase due to reduced labor costs, as well as it promotes user health and wellness. The only real downside is that it does have a higher material cost off the bat.
All right.
And that's it.
Oh. You want. She specializes in business development, strategy, standards, compliance, and engineering with the forest products and sustainable construction sectors. Her work has been published in Structures magazine, and in 2021, she presented to Wisconsin state government officials, making the case for mass timber building code updates to support Wisconsin's woodland economies. She currently serves as the senior director of mass timber at Sterling Structural, a division of North America's largest CLT manufacturer. Michaela holds a degree in civil engineering focused on sustainable building from Metropolia University and Applied Sciences in Helsinki, Finland. And you can ask her at lunch how she ended up in Helsinki.
I don't think I need that. I'm quite loud. Can everybody hear me decently well? Okay. Sometimes I blow those out, so it's kind of a bad idea. Yeah. All right. Well, thank you guys. I know that I am the conduit to lunch, so I will try to make this fun. So yes, I work for a mass timber manufacturer. I am an engineer by background, but studying in Helsinki, Finland, I pretty much only learned about wood. And when I came back to the States and was looking at design engineer positions, I needed a lot more steel and concrete experience than I had. So I ended up in engineered wood product manufacturing. It's a much better place for me. I am very kinesthetic. I like to work with building things. So it turned out just fine. You guys, we've been talking about the mass timber definition here. So luckily all the students did a wonderful job in bringing us up to speed. So I'll just move right on to the benefits. We talked quite a lot about multiple of these benefits, but there's one big one here that I love to keep talking about, which is it supports domestic industry. So obviously Pat touched on that quite a lot, but this is something that matters to many owners and clients. You know, obviously the sustainability aspects are huge,
feeling better in that biophilic environment is important, but to be able to support the woodland economies in your own region with your construction is a really big deal. And so that is something that wood offers. I'll get a little nerdy for not too long, I promise, but there are the product standards that Pat alluded to for glulam, cross-laminated timber, SBL, LVL, which is where we kind of put all of the other engineered wood products tend to live under that standard. These standards are rigorous, they require lots of testing and quality control, so we know that these are excellent products for construction. Pat stole my thunder a little bit here too. All of this comes from lamination, so graded lumber that we is already a completely regulated industry. So that's what's so cool about the U.S. and Canadian supply chain is we're working with what we have. It's very different than how they do it over in the European supply chain. But we buy lumber that already comes from this robust industry, and then the second part of that is our adhesives. So there's the polyurethane and the urea formaldehyde adhesives. It just depends on what kind of press you have. So we'll talk about that here. The very, very important thing about adhesives, we're all super excited about bio-based adhesives and all of these other types of adhesive technologies to improve on our sustainability. Utterly important, it must comply with the ANSI 405 standard or it does not matter for utilization. So it's exciting to get into that research, and now we need to keep pushing, getting more adhesives certified to this standard, which is very comprehensive and takes many years. Production components in a mass timber facility include our finger joiner. They include a planer, so planing down the top of that material, like Pat said, opens up that fibers to receive adhesive. Then there are two different press types. We have hydraulic presses and radio frequency presses. And then everybody at the end moves on to their CNC machine. I will see if this will play, but just to give you guys an idea. So we are the largest CLT manufacturer in the world. We produce a panel every 65 seconds. We are making more of a commodity style standardized panel, which is the direction that we think is really great for the mass timber industry. It's not the only direction. I want to be clear, all of the very custom high-end stuff will still be happening, but just like any other wood product, I-joists are a great example. When I-joists came out, they were such a new thing, and it was so crazy, creative, and custom, and they were showing up at all the standards committees and showing up at the builders and saying, you gotta use this stuff. And now it's the most commodity thing, right? It is in every building. So we want to do the same thing with CLT, make it something that eventually is on the shelves of Home Depot, which I know is not as sexy, but why do we make a panel every 65 seconds? The German engineers that designed our presses asked the same thing. They said, no one needs that much CLT. And we said, don't worry about it. This is our traditional industry. So CLT is not only used in buildings. We started our plant to serve the industrial matting industry. There is a lot of infrastructure development in this country. It is definitely one of the things that takes down the most forests. But what's excellent is when we can create temporary roads. Now you actually can go through those forests and keep that farmland and the agricultural land and environmentally sensitive land safe while we are building our renewable energy fields, or sometimes it's oil and gas, wind power. This is how we maintain that land and keep it well protected throughout that. Some of them have very high environmental sensitivity where we actually have to wash these things and make sure that we're not transferring disease to these spaces. This is another way that we steward our land with wood. So, enough about all of that. Now, what are we here for? We're here to build buildings. So, I want to talk to you guys. Pat set me up just perfectly. How do we drive to a successful mass timber project? There are so many things to consider when we are designing. But, first and foremost, the people that are paying for the project, your client, what matters to them? That's where every project has to start. And the reason for that is so many times you might get really excited about a project. You want it to be mass timber. You are going all out, putting everything together. And then you find out wood into buildings means creating a vision that people want to see for a wooden building. So what is that drive? Is it the sustainability aspect? Is that the aspect? That's what you need to talk to. Do a life cycle assessment. Look at all of the carbon studies. If it's biophilia, they're like, ooh, we're gonna get some, the next one right down, higher rent because people are gonna feel good in that building. Maybe that's what it is, right? Then that's what you need to talk to. That's how you sell the building. Maybe it is just that it's domestically produced. I want to show off my Michigan wood and my Michigan building from a Great Lakes manufacturer, right? Maybe that's what it is. It's very important to have these discussions and know where your client's coming from because they're paying for it. And ultimately, they have the opportunity to buy it, right? So I always tell everybody, this is so boring, but balance those priorities. Take that speed of construction that matters to your general contractor or your installer and the aesthetics that you're pushing through that beautiful design. And what ultimately reigns, often it is cost. So how can we take each one of these and talk to them and say, hey, maybe this is where this project lands, this little star. You guys really want to have this. This might be the most beautiful library in the world. I want it on the cover of Architect magazine. And then they go, actually our budget is a little bit more over here. All right, let's adjust. Always be adjusting so that we can keep these projects in play because they get value engineered out very, very often. What affects that utilization though? What in your design can affect that cost? I think we constantly need to always be aware of this thing because too many times I see mass timber projects go all or nothing. I want all mass timber. Pat mentioned glulam is a little expensive sometimes, right? It's because of the supply chain. If you just want wood in that building, maybe glulam isn't the right choice for that specific building because it's got a really tight budget. So let's talk through a few of these things. Mass timber versus hybrid, right? This project you're looking at, they know it's more cost effective, maybe it's an affordable housing project. How can you get a little bit creative where you get that essence and beauty of wood, but you also make sure that that client can afford it and it's what they want? Sometimes that's a hybrid option. Sometimes that's doing steel spanning structure and having just CLT deck. Sometimes it is just an area of glulam to show off in a corridor. You have to understand where people are coming from with these things. Plus, about 75% of our carbon sequestration is in the plates. So that makes floors, decks, roofs an excellent opportunity to lower the embodied carbon of our project and still honor maybe steel is the best material for your spanning members. So you have to kind of think about these a little bit more because sometimes if you get all in, I only want glulam and CLT, I want everything to be mass timber, and then no mass timber comes out. And that is just devastating when you see projects go that way, where you just say, hey, you know, if you could have used steel here, maybe we could make this project cost out appropriately, but it's too late. So that's why that conversation is so important. So we are looking at how do we standardize, streamline, make a more repeatable delivery. That might not be the right thing for every project, but for us, we want strip malls, we want Chick-fil-A's, we want it all. We want it all out of mass timber. The way that you do that, 90% of this industry is how fast can I build it, how cheap is it, how easy is it for me to order this stuff tomorrow. Standard, repeatable delivery. So, maybe you don't want to be fully on that end, I get it. You still want to make some super beautiful things. Here's some ideas. Design for efficient manufacturing. Go visit your manufacturers. They love it. Go visit them. Come in, see what our facilities look like. Our facility is just south of Chicago. We are very close to you. Come on over, we'll show you. When you see material and you understand how it's made, then you kind of understand where the efficiencies come from, right? So for us, if we're looking at standard repeatable delivery, stick to the rectangle. And I have to tell you something, every single manufacturer builds from a rectangle. It all starts with the rectangle. It starts with our billets. And then we're cutting out of those pieces. So even if you're buying all of these different billets and you're cutting all these curves and stuff, that material, luckily, because we're in the wood products industry, nothing really goes to waste, but it's not being used in your building. It might end up in another market, it might end up in animal bedding, it might end up in mulch, it might end up in combined heat and power, but start by trying to use as much of the billet as you can. Stick to a more more standard grid. Get creative with column spacing. These are kind of ways that you start thinking more modularly towards fabrication. My CNC team, when we bring them a design, the first thing they ask me, how many part numbers are there? Is every single panel unique and different? When you design in that way, where you've got, lots of different things going on, and it's beautiful and fun, and I get it, start to think about how can I bring this down to maybe 20 parts as opposed to 120 parts. It makes everything a lot faster and more efficient when we get to the fabrication facility. So we always kind of talk about it as designing with a module. We run off of 3 base billet modules, 14, 16, and 18 foot. It works for some projects, it doesn't work for others. So always kind of thinking about how you would approach it from a more modular design. Keep taking your fabrication from 100% down to maybe 80%, and then can we get to 60%? Can we get to 50? Can we get to 40? Can we get to 20? Or maybe you just have this super cool edge around the outside where it's taken one panel and cut it into two in a really cool, beautiful, textured format, but everything within the building is just the right size. You can still give that beauty with really good creative design where you understand what the how much fabrication you're putting into there. We always talk too about that simplicity, streamlining, and keeping it repeatable. This comes in with connections as well. I cannot tell you how many times I have seen super, super beautiful connections and then the installer calls me and says, this is awful, I hate this, who thought of this? So we always need to be thinking about our installers too. If we're going to tout mass timber as quick to install, please think about that when you specify your connections. So one of the most common connections is the inset line, right? We all know how to do that. There are definitely a couple of setbacks. What happens on a wooden piece of material where something's cut out? You've just created a gutter. Now it's full of water. It's something to think about for when they're going to be constructed. Is it in a super, wet area? It's that time of year. But we have water mitigation strategies. But again, thinking through from all the way to the factory to the job site helps us all work together. The fun thing about mass timber is it is very collaborative. You do work very collaboratively with your manufacturer. I'm sure you'll hear that more this afternoon with some of the folks from the design teams that will be talking to you about these things. Fabrication levels are important, as I said, and one of the big things is we talk a lot about prefabrication being a really, really great benefit to this industry. It can and it can't, right? So I think some of you have worked with MEP engineers. They take a little while to get their stuff back to you, right? It's true. So when we're talking about getting you a project in time, and I'm still waiting for those MEP penetrations, I can't start fabricating that project. And so all of that pre-construction work and all that prefabrication work has to also correlate with your timeline. The other thing it needs to correlate with is your local labor pool. So there are certain areas of the country where we have very, very good carpentry labor pool. We've sold projects with commodity glue lam where they cut the glue lam on site. They were like, yeah, just send us back glue lam. We'll do it, no problem. Because they're a group of very highly skilled carpenters. There are also other areas of the country where labor is very limited. Very limited. And anything you can do in a factory is going to help. But it's not always cheap. So again, that's where that conversation and being more collaborative with your installer, with your contractor, ask questions is very helpful to work together that way. Because are we going to save time is ultimately the question with prefabrication. The answer sometimes is absolutely yes. The other answer sometimes is, hey, no, just send me those rectangles. I've got a hole saw, and also my plumber puts the pipe wherever he wants anyway. Even if you put that hole there, it's probably not going to go there. So just think about all of those things. Don't always think, I love that Pat said mass timber is not the silver bullet. It's true. We have to work with steel. We have to work with concrete. It takes a hybrid approach. Prefabrication is also not a silver bullet. There's a much more to the story, and it takes critical thinking and asking people within your project team what's going to be helpful to them. moisture mitigation plans, what types of coatings, you guys talked about that in your presentation, and then also the rigging. How can we continue to make this very helpful for installers? So you also have to know what your impact is with specification. Understand the certifications for your fiber. You know, I heard FSC, we've talked about SFI, there's multiple. You really need to know what the lead times could be for that, right? Or maybe they can get one thing or another. Provide that alternate. Really understand what you're asking for. So, ooh, I missed one there. Oh, it's back there. Sorry about that. And then also think about the freight. So if you are specifying one specific layup that only comes from one manufacturer and they are 2,000 miles from your project, you've just limited yourself. Very, very much so, right? And also, are you specifying some very custom layup that only comes out of one facility in Austria? That's fine if that's what you need to use, but if you can think a little bit wider and provide multiple species options, multiple layup options, challenge your engineer, say, hey, I need 3 options, this project's going fast, and I need options with manufacturers. I can't get pigeonholed into one because I gotta move quickly. Work with your design teams on that. And there are an infinite amount of layups, but when we talk about domestic supply, we get laminations in 2-by material. People say, oh, well, you can buy 1-by material. Well, here's the thing, 1-by material is not half the cost of 2-by material. So now I just have a more expensive, smaller layer. And that doesn't work for the majority of projects, right? We need to be thinking about how our supply chain works here. I understand that Europe was a little faster on getting some of these mass timber products more heavily adopted in their region. Their supply chain is very, very, very different. They own their forests, they cut their material to anything that they want it to be. We have a very robust 2-by, 4, 6, 8, 10 supply chain, and that's what, if we want to make this a very affordable, accessible product, we have to work with the reality of our supply chain. So understand your impact when you specify a species of layout. Consider the transportation. I think it's great that we're talking about transportation, and I love that you guys bring that up. It's also important to remember that wood moves along the supply chain. So just because you get your mass timber product from a certain location, that does not mean that sawmill that is only getting stuff from about 50 miles around them is only 50 miles from that manufacturer. Sometimes they are getting wood that's a little further away. It's important to ask those questions. If you are looking at lowering embodied carbon, ask them, hey, how far are you guys sourcing wood? So for us, as an example, we source the most of our material from ourselves. We are one of the largest private purchasers of southern pine in the country. Per plant, we go through 75 million board feet a year. That is a lot. You just heard the documentation, that's how much they make in a year. So we need that for each plant. So we go to our beautiful, large wood basket of the South, and we bring the majority of our material up on rail. Our facility is on a rail spur, very low carbon transportation. The ever sourcing with fiber certification. So Pat did bring this up. As you just learned from Pat, and there's so many amazing people that have gotten us to here today in North America, very regenerative, very sustainable forests, keep it continental. If you just start there, if you just start by, I am going to get my wood from the US or Canada, you're golden. We are making more wood, we are growing more wood, we know it's sustainable. Certifications can help though, right? Sure. You want a little bit more there, kind of like buying the organic food. So it's nicer, like go to the organic food when you can, when it makes sense. But remember that going back to maybe a conventional vegetable versus going to a hot dog because you can't get the organic vegetable doesn't quite make sense. So let's try to start with the basis of wood and add from there. SFI, FSC, PEFC, ASTM, B7612, American Tree Forest, there are so many different standards out there. But it's really amazing that we can also rely on the fact that a lot of our state also has best management practices. I will not go too much further into this because Pat just laid it out so beautifully, but definitely think about this. An example is, if you specify FSC wood, you've limited your supply chain, cost just think about it, right? Doesn't mean it's the only thing to do here. Understand the limitations of that supply chain. SFI is very common for southern pine, thanks to Pat Layton, but it's not very common for other species. FSC is very common for Doug fir and SPF, not very common for SFI, or sorry, I'm sorry, for southern pine. So now you're limiting your supply chain again.
There's more SFI in the Pacific Northwest than there is FSC.
And there you
There's
go.
there's no FSC.
FSC is a very small supply chain. It's a very small supply chain, and the cost mechanisms are different too, so oftentimes there'll be a price premium. They're all good programs. I would just say look into the programs, understand what the rules are. You can also go through sustainability by requiring your manufacturer have an EPD. That's a great way to push them to think about their carbon emissions. Or material health certifications, HPDs, declare labels. Ask this of your manufacturers. It forces them to look at their own sustainability. That is a very, very powerful tool that architects and engineers have. Compare your costs holistically, right? So this is one that we see a lot where we compare maybe some of the upfront costs on mass timber, and it's not the same. Things are not always apples to apples. For example, if you have a beautiful exposed CLT roof and you don't need to add any more ceiling material, is it really the same as a structure that you then have to add in drop ceiling and add in the, is it the same? It's not always the same. So you try to look at the full assembly or work with your team to look at the full assembly if you're really doing that cost comparison. What's included off-site? This is a fun one. A pick is not a picking. This is crate picks. Sorry for construction here. Taking a really long, big, huge panel and getting it up onto that thing. It takes a lot of people. I don't know if you've seen a little bit of wind with a CLT pick, but it is like a wet noodle. So sometimes, for certain projects, it's better to cut it at small intervals to make that installation a little bit faster. Or, now you can have a lighter crane. Lighter cranes are significantly cheaper than bigger cranes. And maybe you go, oh, but now I've got more picks. Well, now you can have 2 lighter cranes that are still cheaper than the bigger crane. So it's just important to have those conversations with your installer and start to learn more about that. And it's not the same for every project. Every project has their own logistical site advantages and disadvantages. You might be in a really cramped city and getting wide loads and long loads might not be a possibility there. So, there's a lot of things to be thinking about, which is why we love to work together. As far as Sterling, what I've told you is we are really looking at being more modular, being more of a commodity style CLT product. Of course, we still have all the fabrication, but we're trying to train designers down to more limited fabrication for faster, scalable development. We tend to come in at a lower price point because of our purchasing power in lumber and because we are making this more repeatable element, and it improves our lead time. We offer 100% U.S. wood. Every single stick that comes into our facility was grown in a U.S. forest. Our bread and butter is definitely southern pine. That's what we make the majority of our products out of. But we also are certified for spruce pine fir south, which just means south of the Canadian border. That's just U.S. spruce pine fir. And then eastern hemlock. We work with our teams as far as any of the design assist and coordination. So we have engineers and architects. That's another career path for many young architects. I've got someone I just got out of a master's program who is really excited to be able to work on tons of different projects and lots of different things as just doing the CLT design. So if you guys ever are interested, come on down to the Sterling plant. We'll introduce you to our CNC team. You can play with some big machines and see how your BIM skills could be utilized in that type of environment. Sorry? Oh yeah, you're coming. Oh gosh, you're coming. Great, you're already going to be there. Make sure to have fun with the CNC. Project management and logistics is another really important thing with a mass timber manufacturer. Getting these panels there, getting them there in the right sequence, working with your installer so that we are the installer's best friends. We don't want them to go, oh, I'd so much rather put in steel decking. We want them to go, I love putting in CLT. I love putting in glulam. I love that the erection sets are so easy to follow. We have all the machining, pricing transparency, adding in complementary products and sustainability support within our team as well, and most manufacturers will have exactly the same. We are more than CLT, that is what we manufacture, but again, it's very important to be thinking about these complementary products. So we provide factory installed weather resistant barriers when that makes the most sense. We provide coating, so everything comes edge sealed, but then do you want a face coating on there? We sell glue lamps through project partners. We also sell steel packages through project partners. So we are trying to play very nicely with all of the materials. And then pre-applied rigging so that they can pick those things right off of the truck. Here's just a wide variety of our projects. I think one of the most fun ones is on the bottom right here. This is a hotel at Fort Liberty Military Base. They are using CLT for military base hotels because of its exceptional blast resistance and because they can buy an air. They're looking at doing the same thing for embassies overseas because they're easy to put into a container and build things over there. So there's so many amazing markets for this material because of the different attributes and aspects that it has. The bottom left is an interesting one because it's I think one of the first emergency care centers that use CLT in the lobby area. And they're actually going to do a biofluidity study to see how it makes people feel. When you go into urgent care, you never feel good, but a little bit of warmth, can it help? They're really going to look at that down at University of Florida, is where this center is. So, rounding this out, I know everybody's hungry. We are looking at getting as standardized as possible, but it takes partnerships with designers in the industry to move away for the right projects from this very custom, on the silver plate, whatever you want, we'll print it out of wood. We're not printing it out of wood, we're cutting it out of wood. It doesn't come in those shapes. But we do want to be supportive of those designs. But how can we get this into more buildings? How can we get it into single family with light frame walls? We want to be doing much, much more. We do have these two facilities, kind of strategically located in the Midwest. A lot of the concentration of manufacturers is up in the Pacific Northwest. We've got Smartland down in the south with us here. Mercer has bought the Structureland facility that is also in the south here. But there's really not as much in the south. We could use a lot more capacity. And then up in Canada as well. That is really where I will leave it. I am available for questions and all of those things. I'm around. Here's my info, and I'm sure Carl has it as well. Thank you guys for your patience while I know everybody's stomachs are ready.
We're not doing much yet.
Oh, God.
You and
I
Pat,
like you.
You and Pat are coming back up to the front.
Oh, okay.
Well, that's it.
And don't overdesign. She didn't say, but I just learned this. We are building a building at Clemson right now, and the architect decided they wanted to seal all the wood on the interior spaces. And I'm like, we're not sealing this wood. Why are you doing this? It was $150,000 worth of sealing that they wanted to do. Stop it.
Let them ask a question.
Just let me get that. I mean, you got a rock.
Oh, I know.
Here we go.
Questions?
Hello. I'm actually one of your other panelists. I don't think we've met yet. I'll be talking tomorrow. But I was really interested in what Pat was saying, and you're going to laugh at my presentation tomorrow because I'm going to be talking about how our wood came from Austria. It's So I'm from here, but I'm based in Portland, where I'm going to be presenting an all-wood building that we did tomorrow. And one of the things that's really been a big topic of conversation in the Pacific Northwest is the lack of sustainable, like true sustainable forestry, to be able to tell that it is, because the way the wood comes into the mills, you can't identify exactly where it's coming from. And it's not even FSC, it's almost everything. And I think you mentioned for like an additional price, the mills won't do it now. Even if you offer them more money, they're not going to stop it for one project. We have developers who are quite upset about it because, and they can't get what's to their minds like a truly sustainable product that they can like then market, et cetera, which is one of the reasons we did end up going with KLH, because they own their forest. So maybe Pat, this is more just like a question for you, because for us, and like I'm not a forestry expert, obviously I'm an architect, and we only know what we're told by people down the product line chain. But for us, that was one of the reasons why we did go overseas, even though we're right in the middle of U.S. and Canadian forestry. So I don't know if you want to speak. I know you're from like the southeast, and we didn't really talk. Yeah, the Pacific Northwest. So maybe that's a total erroneous take, but that's been the conversation amongst like architects trying to specify a certain kind of sustainable product, and developers as well, is that there just isn't the market for it for those few products. The mills don't want to stop.
So you said KLH owns their own timberland?
I don't know if
They
they own it, but
So
it's
I'm
all
just gonna tell you,
vertically,
they
it's all
don't.
vertically like managed.
Okay.
Yeah.
So, and it's a difference. But I am
Yeah.
gonna tell you this about Austria. Austria is actually gonna cut down all of their trees because they were planted using after World War II, when so much was destroyed, they were all planted with bad genetics. So the entire policy for forests in Austria, they're gonna cut down everything and replant it with good genetics. So they have a policy of what they're gonna do. Where in the Pacific Northwest, this is my question back to people in the Pacific Northwest, where is forestry not sustainable in the Pacific Northwest?
Well, there's the big timber wars controversy of the 90s with the spotted
Where
owl.
is
But
forestry not sustainably practiced in the Pacific Northwest?
Well, I don't know how to answer that question. I'm
right.
an architect.
And so when you ask me, well, where can I get sustainable timber? I'm going to go everywhere in the Pacific Northwest.
Yeah, I think.
I know, because
Yeah.
I work with PGF too. So.
No, I mean, no, the airport, the amount of sourcing, especially with like Yakima and Turkmenish, like, but for most of us, we can't afford that kind of thinning forestry. You need the kind of like clear cut.
No.
Well, that's what the industry.
But I know that, and
yeah.
I'm telling you, they're wrong. So there is sustainable forestry everywhere in the Pacific Northwest. And if you are buying from a mill, and you actually can go out and get the data about what's out there, how many people are private landowners or public landowners. But the forests of the Pacific Northwest are sustainably managed. Now, if you consider not sustainably managed an urban clear cut that had to go in because it was people were building a housing project around Portland or Seattle because they're expanding the housing, and you clear cut it, it's not going to go back to forestry. That's really not sustainable. But in reality, it's an urban clear cut, and you don't want to waste the forest. But I would tell you that, in my opinion, and in the opinion of the federal government and the state government, that the forests of the Pacific Northwest are sustainably managed, and you can get the wood, and you don't need. So why do you want to know the specific owner? You want to know who owns the trees.
Yeah, I think it's a certification issue. Like people just want that piece of paper, and if we can't give them that piece of paper,
yeah. And you can get it in SFI or FSC. FSC is much rarer, but SFI could give you chain of custody because they know. I mean, every logger basically, when they go out to a stand and they cut the trees, and it comes to a place where you transfer ownership, you literally either to it leaves the ground and it goes to the first owner, so a sawmill. They know where they bought it because they probably have to send a check or a receipt to somebody so they know where they bought it. But it doesn't get marked on the log once it gets unloaded.
I'm going to ask you some more questions later because that's a lot of work for an architect to do.
Right, and you shouldn't have to do that. Yeah, you should feel comfortable.
I'm not
going to
do
that.
that.
Everywhere in the
Yeah. Well, thank you. Yeah, I want to talk more later.
But it seems like an important issue in terms of being able to publicize,
specify, yeah.
For your client. Right? Back to Michaela's point. This side. Back to your point, what are the clients looking for? Here's something that the clients are looking for, and we couldn't get that certification. So one thing I want to ask, I know there's a question in the back, but we also saw some student presentations this morning, and so any feedback to the students in terms of what you saw this morning?
Oh, there was one slide. You guys had a slide that was percentage breakdown of how people felt in the space. First of all, I
So let's get her a picture of the
I
slide.
need that slide because I thought it was really wonderful. I mean, I would say for all of you, what I love about the change over the last even 5 years is you're exposed to it. You even know about it. Do you know how many people are in the industry now and go, oh my gosh, I've never heard of this mass timber stuff? And then we get to talk to students and y'all are like, you guys are chumps, I know all this stuff. So I can say that it is very cool that a lot of you are coming from the exposure space, understanding the carbon impact. That was really, I love that every single one of you touched on that in a very positive way, and it gives me a lot of faith and hope, especially with this next generation of designers. I think some of these extensive forestry conversations that we were just having right here come from a lack of understanding in a very specific generation. We got way too much Lorax and way too much fern gully and a little bit too much Captain Planet, where we got confused and we don't understand forests. I manage an 80-acre forest in Wisconsin, and I can tell you, do you know how much stuff I have to cut out of that forest to keep it healthy? And you can feel it. You cut out ash trees that are diseased, or you cut out a bunch of buckthorn that is just not supposed to be there. I have an oak savanna, they're supposed to be very wide and open, and you can feel it. You cut those trees down, the forest goes, and so that's what I always tell everybody, get with a forester. Like, gosh, if I could walk around with Pat every day, I'd just be a lot smarter person. But every single forester I've ever met is the same way. I'm just an engineer, but I've gotten very lucky to be able to I've gotten very lucky to be able to walk the forest with foresters. I was actually the certification agent for ASTM B7612, which is a long name, but it's basically a standard that mimics chain of custody, SFI, FSC standards, but just through ASTM. And the Oregon Department of Forestry, every single forest they own is certified to that standard. Every single one of them. That still doesn't do it for architects. I audited those.
It's not us. It's not us. It's
no,
the
I
science.
know. We get it. We get it.
I may know your point.
Yeah, I know. I think we know. We were talking. But anyway, so that's my
One hit for all students. Don't put so much on your slide. And architects, sorry, I hate to criticize, but I've seen a lot of videos. You try to put too much on your slides. Just put the big points. You taught, and I want to tell you, that group that came up and your slides didn't work, way to go. You jumped in and got it going. That's really impressive, because I will tell you, if you talk a lot to people, your slides are not going to work Monday. Or back in the old days, we actually had cartridges with real.
Okay, there's a question here before we get off on a whole other tangent about slide carousel.
Way to go.
Yeah.
Excuse me, I got two questions. I'm from College of Management, LTU. The first one, that we heard before that carbon sequestration has limited life. So woods get the carbon from the air, but then release it later on. So does it affect the sustainability that we're talking about? And the second question is, in Florida, as you probably know, because of hurricanes and high winds, they changed their regulation and codes for the buildings. Does it affect the usage of mass timber because of those kind of conditions?
Yeah, okay, so carbon storage, if you put it into a long-lived product, so if you're building a building that's going to last 50 years to 100 years, you're storing that carbon. So there's the carbon uptake as the tree grows, and then there's carbon storage. And so that you can extend the life of products, because every product in this building, most of these are not storing carbon, but wood can absorb carbon and then store it for the life of the building. So what I would love is to see buildings that are 100 years old or 200 years old, maybe have wood. But as trees grow, just as people do, if we drop, trees will drop limbs. They will not absorb as much carbon over time. If they get disease and they fall down in the forest and they die, and they release that carbon back. So what the idea is that you actually have the trees grow, use them in long-term products, or even if the product ends up in a landfill wood and paper products in it doesn't degrade in a modern landfill. We're not degrading. So there is a long-term storage when you are using things that are either going to go into a modern landfill or into a building. Like the building that we have that was built in the 1890s, those trees grew from like 1800 to 1890, and now they have been stored, that carbon has been stored from 1890 to 1924. That's long-term storage. I can't get much better than that. So that is what I would say. So there is carbon storage. And by the way, in Georgia, there's now a carbon storage market. So if you're building a mass timber market, if you're building a mass timber building, you can actually get carbon market credits that will be sold. You can buy and sell because you're storing carbon in a long-term manner, just like biochar stores carbon or something like that. So there are markets for that. That's an exciting new market where you can actually build a building and get your carbon credits for it. And that's where we're headed.
And then quickly on Florida. Florida is a wild example because every single jurisdiction in Florida is different, has different rules. It's a very, very different engineering and building regulation environment. So to your question about some of the changes that they're making, it still just goes down to each county. Like even with Miami-Dade, like they have their own certifications for things. So I think that there's actually some pretty good advocacy in Florida for mass timber utilization. Obviously, there are different considerations when we use it in places like Florida. It's the same for our matting industry. It's more swampy, there's more termites. You got to think about the way you're designing. So maybe you've got a bigger concrete podium. It all works out. But there's actually a lot of positive movement in Florida, I'd say. And I think any of the updates that they're making so far are affecting mass timber specifically, other than kind of some of the jurisdiction-specific things.
Oh no. Thank you both for the presentations and the students. I have a question, probably more from Michaela, but as a practicing architect and working on projects where, the goal or the dream is to have a manufacturer in the process very early on in the design, but that's often not the case and can't be the case in some, where it costs a lot of money to have design assist, and the client may not be willing to put down that much money so early on before it's site plan, before it's entitled, before they get their loans altogether. So could you talk about maybe just the nut and bolts process of how you see a project come to your design before it gets made into panels, and maybe it's not working well for you, and how you respond to the architect and how you work together, really specifically for students when they get into the field, how they see that collaboration working together, maybe later on in the process.
Sure. So I think a lot of it comes from mass timber is not a very standardized environment yet. Everybody's kind of manufacturing a little different. So the first and foremost, any opportunities you have to visit suppliers, I say the same things to design teams too, practicing design teams. Go visit as many suppliers as you can, learn their strengths, learn their weaknesses. We'll tell you. I mean, we're pretty straightforward. I'm absolutely right that projects are more successful and they maximize the benefits of mass timber
you want to build a mass timber building, get an engineer who understands mass timber. Because sometimes they don't understand it and they make stupid choices. But you also have to be very strong with talking to your mechanical engineers. HVAC is the worst nightmare. Because they want to just run their runs, or they want to put the conduit where they want to put it. That can't be. That just can't be. So really, that's why I like integrated project delivery, where everybody sits down at the beginning. Let's all make this best for everybody. That works well. In universities, public universities, procurement never works right. Public procurement is God. So you just got to sort of know we have these three manufacturers that we can work with. Let's go with design and be flexible with this, and then see how it ends up. But certainly some of the most prominent things that were named here today, the UMass building, the design building at UMass started as steel and concrete. Other buildings started as steel and concrete and then came into being a mass timber building, or becoming a hybrid building. And so really, when you get to that point, being smart about, well, how can we, is there a way to replace part of this with mass timber and really get it, even after you're at CD? Yeah. What can we do? Can we work this? Because I think that's where the Amherst building was at CDs when they changed and went to wood. Yep. So just think about those things. And they got a lot of benefits. It was easier for them to go wood than steel and concrete. Cheaper. So you got to know. Yeah. Yes.
Answer.
Yeah. It did end on that.
Okay.
So, first of all, thank you so much for your presentations. They were really wonderful, and coming from a business point of view, there were a lot of key insights that, as a business students, we did not realize that these many things goes into mass timber. Coming from mass timber, key elements like the CLT and the nail laminated structures. As you mentioned right now, like the last minute changes can cause a lot of impact on the project. So, on a financial point of view, if there is a change in the last minute in these kind of structures, what would be the cost estimates and how does that impact the overall project in long term? Will that be more sustainable or will it reduce the efficiency?
So are you saying changes like post-contract?
Definitely, like we fixed up on like let's say CLT, and then if towards the middle of the project, like the value at risk they changed, and then we switched to something else and make it more of a hybrid project.
Okay. Yeah, so typically we don't go into like product contracts until things are pretty well set. Like usually the contractor's not going to purchase anything until they've at least decided their materials. So that said, I think where some of the changes come in is when project teams aren't very upfront about what they're gonna do, and we make a whole proposal, we go through the whole presentation, then we get there, and then they start to, this is what GCs do sometimes. They start to poke and they go, that's in the scope, right? And you're like, well, actually it's not in the scope, but that's in the scope. And also we have all these new MEP penetrations, but that'll just be fine, right? We can still get it tomorrow. So the way we manage that is definitely through very strong relationships with the design team, get through your RFIs as clear as possible, have a good project scope. But when those do happen, it is a change order, right? And so typically, we'll try our best to call it out as soon as possible. So if I start seeing changes come in on drawings and we're in the middle of our shop drawing development, I go, hey, do I need to stop my team? Because having them start up again and do more iterations costs everybody money. So it's the collaboration, I would say, that keeps that stuff down, keeps change orders down, and allows them to consider the cost of it before it just has to be the cost of it.
Yeah, massive collaboration is the name of the game here.
Yes.
And
the name of the symposium.
Wow. Because this is it. This is where the rubber meets the road.
It's also super interesting to me that I think we maybe selfishly like the idea of supporting architecture students by pulling in engineers and business students.
Yeah.
But what I'm hearing with your question is that I'm hoping that we're exposing business students to the potential of things within the construction industry. And we need smarter business people and smarter developers and a a lot smarter people in the construction industry from that side too. So
And read the McKinsey
please.
report.
All right, a couple more questions.
Yep.
Hi, I'm from the architecture department at LTU, so designer, right? Question for Michaela. Kind of earlier we were talking about how your firm, of course, likes rectangles, right? And designers, we're often trying to push the limits of the material, right? And some don't like so many rectangles.
Oh, I get it.
And Pat mentioned Eiffel Tower, right? And all these materials, when they came to being, designers try to push what they can do. And think about mass timber, especially as a very machinable, right? Let's say material. I guess the question is with your background in Helsinki and the European side of things, right? Thinking about firms like Erling, which you both found, who can do very custom fabrication with mass timber. On this side of the pond, is it more of a kind of industry supply chain issue, technology issue, industry issue that, let's say for designers here, make it more prohibitive to get to the sort of European, let's say, level
Yeah.
of detail?
This is a great question. I mean, I think where you have to start is what kind of project are you looking at? Because in Europe, if you actually look at the majority of wood buildings that are multifamily, that are this, those are all rectangles. They totally are, right? It's when we get into these really beautiful grand Groupon, studio gang, these types of things where now you're getting into this. And if that's where you want to be, the budget's going to be a little bit bigger and you might have some more room. I would say domestically we have great fabrication. We have a 5-axis CNC. We have a 2-axis saw that we've designed ourselves to go really fast. We have a huge fabrication area with like 5 different lines. And so any of you are into like digital fabrication stuff and you're coming to the plant, go talk to those guys. They love to. Our CNC leads a little shy. Just push it. He'll be fine. But we have the capability. But I would say in the States, we need lots of big scalable development now. And a lot of big scalable development now takes making the most efficient choices for manufacturing. And so I'm not saying that you need to just make boxes. I really am not. What I'm saying is, let's look at the edges of the building and say, or just any area, and say, can I get my fabrication down to only 20% of panels? You can do a lot with rectangles in between some really cool stuff. Like we had an oval roof for a gymnasium, and at first I looked at it and I was like, oh god, the waste on this thing is just going to be so crappy. And it wasn't. We designed it really well where the center was all rectangles, and then it was just these things around where you could actually use half of a panel.
Yeah.
And exactly. So I've been working with some kind of big high-end design teams that want that really sexy texture and things like that. And that's how they're doing it. They're saying, okay, 80% of panels like rectangles. What's some really cool ways I can cut up these 20% of panels where I'm using the whole panel, but maybe I've got lots of cool edges, and then we just throw it on the CNC. So it really comes back to design.
I actually think that wood gives you a lot more flexibility to push curves and unique designs than steel and concrete do. Because you want to talk about the ultimate in straight line, steel and concrete. But when you really want just look at this feature right here. And you did that with students who probably weren't trained carpenters.
If you look closely, you'll get a sense for that.
But look what you did. Look at the beauty of this. You can do so much great things with wood because it is such a flexible, bendable, and there are craftsmen. There are really great craftsmen out there. Studio Gang, one of my favorite things is their glue lamb thing in the park. Mm-hmm. Love it. Yeah. And it's just finding those people, those craftspeople, and that is the nice thing about wood, is that there's craftspeople who can do that for you, and they're there, and you just got to find them. And Jeannie is really good. Oh yeah.
So we have 2 more questions between us and lunch.
Hello. Beforehand, I just need to thank you. It was pretty nostalgic to hear a lot of stuff regarding forests, trees, and all. And my question is regarding selection of trees and the choice of raw materials. Is there any specific age group of trees you guys prefer for manufacturing? Like, using mass timber, you guys will design the roof, beams, and the basement, and the ceilings. Is there any specific age group of trees you particularly prefer to manufacture those stuffs?
So one of the answers is that trees grow differently in different parts of the world or country, even within the United States. In the southeast, a pine tree is pretty well mature at age 25 to 40. If I were in northern Quebec and I wanted to find that amount of wood growing on a stem, it might be 300 years old because they grow very slowly. And out west, you have some species that grow very fast and some that grow very slow. And so, no, it is species dependent to a certain extent, species and location. So even within the South, if you've got poor quality soil, the trees are going to grow much slower than on a very good quality soil. And so really understanding that, every acre is different, every tree species is different, and you have to figure it out. So it's not about age. Yeah. It can be about growth rate. Yeah. It's more about growth rate and what's going to give you the best species. But again, we build because we are highly regulated in the building industry by codes and standards. We really, and that's why hardwoods are got a ways to go before we ever can do this with hardwoods, because we don't have the standards all the way through the system and the technology to estimate and test their strength on a production system. So when we get there, we'll have it, but we aren't there yet. So there's just a lot going on. We're a highly regulated industry when you really think about building buildings, because no one wants to feel unsafe going in a building.
And it's also, too, going back to really trusting. We have a very robust lumber supply chain in this country. And so as a engineered product, wood products manufacturers, all engineered wood products manufacturers that use lumber or LVL as their lamination, we rely on that industry for their own codes and standards. So and they have it for every single species group.
Yes.
And so you might get a southern pine species group. They might be 25 to 30 years old when they're cut down, but the sawmills are the ones that manage all of that. For spruce pine fir, Pat kind of alluded to the sizes. We actually have length limitations when it comes to spruce pine fir in lamination. And so it really just depends on the species, but we're so lucky to have such a robust supply chain to work with. But then as designers and business people, all of it, understanding what the limitations of our existing supply chain are. Because when you we can push the supply chain, for sure. We are trying to get better, more standards built for hardwoods and more utilization of different types of species. We're doing all of that work, but we also have to understand the reality of where we are now when we're talking scale. If it's your one-off, beautiful, super curvy library that's going to be on the next cover of Architect magazine, you can probably get something really obscure. You can probably go get some hardwood CLT and multiple different things. We can support that. It's a much different cost level than when we're talking about building hundreds of multifamily affordable housing developments. So it's really, what are you working on?
We are right on time. So I want to thank the panelists this morning. I want to thank the students for your presentations.